They ruled the planet for over 170 million years and then disappeared. History says it was a huge city-sized asteroid that came from space and hit the land of the Yucatan Peninsula around 66 million years ago. It caused terrible environmental changes, debris in the air blocking the sunlight so the plants couldn't survive. Temperatures on Earth's surface plunged. The animals were struggling to survive until they finally went extinct. At least, that's something many paleontologists believe happened. Now, they found out dinosaurs were about to go extinct even before the asteroid. Their diversity started to go down 10 million years before the asteroid. Older, long-living species didn't evolve enough to adapt to all changes in the environment, such as higher sea levels, massive volcanic activity, cooler periods. Dinosaurs preferred a warm climate because it helped them to keep a stable body temperature. Dinosaurs lived on all 7 continents, even in Antarctica. That's because it wasn't all ice back then. Around 90 million years ago, Antarctica was a swampy rainforest with a warm, pleasant climate. It was even in a different location, only 560 miles from the then South Pole. That was the time of the warmest climate on our planet. The sea level was 560 feet higher than today, and the tropical sea surface could reach temperatures up to 95 degrees. Antarctica still had something like polar night, months without sunlight, but the climate around the South Pole was mild and temperate, with no ice masses. Dinosaurs didn't shed their skin in one long piece like today's reptiles do. Scientists believe they shed it in small pieces, had something like dinosaur fur. There was a dinosaur, Pagomastax, that looked like a cross between a porcupine and a parrot. It had 1-inch-long jaws and ate plants. It had a short beak and self-sharpening long teeth. They were like scissors this small dinosaur used to slice up plants. Our modern lion has a mighty bite, but a big and scary T-Rex bites more than 2 times stronger. The king of the dinosaurs has the strongest bite amongst all land animals, 3.5 times stronger than today's record holder, the Australian saltwater crocodile. It also had the longest teeth, almost 10 inches long, the length of an iPad. Most modern animals are either warm-blooded or cold-blooded. Dinosaurs were somewhere in between. Scientists think they mainly were mesotherms, which means the activity of their muscles could warm their bodies, but their body temperature could fluctuate too. Many dinosaurs, such as Triceratops and Stegosaurus, had spikes, plates, horns, crests, or other bizarre structures on their bodies. In the beginning, scientists thought that's for things like defense. They had neither sharp teeth nor hooked claws on the toes to hunt. But soon, they expanded the theory. It was probably a way to impress their mates and identify members of their kind. One species, namely Pachycephalosaurus, even had a funky bone hat on top of its head. Scary, tall as buildings, massive. That's what we saw in the movies, but dinosaurs mainly were human-sized or even smaller. Bigger bones were easy to be fossilized, so that's why we mostly find gigantic species. Eoraptor, or dawn stealer, was the first named dinosaur. Small and toothy, like me, it got its name because it comes from the dawn of the dinosaur age, the size of a German shepherd, but probably not that friendly. Arched back, sharp bony plates, curved tail. Ankylosaurus were some sort of giant, muck-spikier dinosaur version of an armadillo. Its weak spot was a soft underbelly, but meat-eating dinos that were after this one had to flip that guy first to get there. Still, it was really tough because of their impressive gear. Scientists believe they even had bony eyelids. Some dinos ate meat, others plants, and some of them could nibble even on pebbles. One dinosaur, called Gallimimus, couldn't physically chew all those plants it ate, so it would ingest pebbles to mash up the food. Gallimimus looked like some weird alien mix of dinosaur and bird. But it couldn't dribble a basketball because its wrists weren't capable of keeping the palms parallel to the floor. And they had no three-point shot. The largest dinos were plant eaters. Meat eaters, or so-called theropods, were mostly smaller. One reason is that plant-eating dinosaurs were very greedy. They would devour enormous amounts of food, sometimes even swallowing the entire branches without chewing. Some of the biggest could eat a ton of food every day, like a bus-sized pile. There were also more plant-eating dinosaurs than the other ones. Scientists are still not sure if meat-eating dinosaurs were able to coordinate themselves in hunting groups. They were probably unfriendly towards each other, especially when it comes to sharing prey. Fossils, and the shape of delicate bones in the eye, tell dinosaurs mostly roamed around during the day. Scientists think only smaller meat-eating dinos, like Velociraptor, were active during the night. They were after those small mammals snuffling around and trying to find food while big dinosaurs were asleep, or that's what they thought. Those small mammals were usually burrowing animals that survived both dinosaur reign and ice age hiding underground. Not all mammals were hiding from dinosaurs. Some small but sneaky creatures, like Reptinomammus, would steal the eggs from big dinosaurs, which was a big thing considering they had to trick the mama dinosaur first. Researchers believe dinos tried to flap on the ground to get faster at running up inclined terrains to catch their prey. Such behavior caused them to learn how to fly, which of course happened through thousands of years. Dinosaurs were fuzzy and fluffy. They are related to birds, but even those early dino species that didn't fly had feathers, like gigantic, scary, fuzzy T-Rex. Movies lied. You just can't stand still and expect a T-Rex would pass you by. Its vision was probably better than one today's raptors have. Even without it, they still had a pretty good sense of smell. Running could help it though. Scientists calculate T-Rex could probably run at 12 miles per hour. It would shatter its bones at a greater speed. Some dinos had tails more than 45 feet long. Tails helped them to keep their balance when running, especially those that walked on two legs. Velociraptors were not like raptors we see on the screen, but more like some sort of prehistoric chickens. Small, a little bit bigger than a turkey, 2 feet in height, probably had feathers, hollow bones just like birds, mostly loners. But they were probably among the smartest dinos. Their brain was big compared to their bodies. They were as intelligent as today's ostriches. The name Velociraptor means speedy thief. Stegosaurus had a pretty big body, spiky plates, and a tiny brain, the size of a walnut or lime. But at least it had its own air conditioner. Researchers found out its spikes were filled with veins that transferred blood and developed a theory that they were cooling its giant body that way. Dimorphodon was the flying reptile with a wingspan of 8 feet and multi-purpose teeth. Teeth in the upper jaw were longer, sharper, and better for catching food from the water. The teeth in the bottom jaw were better for holding the game in transit. One of the first potential dinosaur discoveries was in China 3,500 years ago. No one knew about dinosaurs then, so people thought teeth they found could belong to dragons. The Hadrosaurus was a duck-billed dino with more than 1,000 teeth. When they would fall off, it could grow new ones indefinitely. Dinosaurs' eggs were pretty big, some as big as beach balls. Now that's a number. The Baryonyx was a big fan of fish. Its name means a heavy claw, and it got it because of big extended claws that were pretty sharp and made up the thumb of each hand. When catching fish, they used the claws like spears. Mosasaurus, also popular in movies, was not quite the dinosaur but a marine lizard, closely related to monitor lizards and snakes. Like a snake, it had jaws that could expand when swallowing the food. These creatures were speedy. They had a tail fin and flipper-like paddles instead of arms and legs. Researchers believe they had a weak sense of smell and poor perception of depth, so they had to develop a unique hunting technique, waiting for their snack to come up to the surface for some air. Now, thanks to new fossil discoveries and technologies, we're getting to learn more and more about the biology of dinosaurs. Some people don't need to know more than the fact that a few of them were colossal, terrifying, and vicious. But for those of us that do, the use of comparative biology, pigment analysis, and powerful new X-rays have allowed us to gain insight into specific features, such as their colors, eating behaviors, and the shapes of their tongues. Yes, that's right, the shapes of their tongues, which, for a long period of time, was something of a mystery. This is because soft, fleshy dinosaur parts are hardly ever retained in fossil form. But thanks to the discovery of some surviving hyoid bones, which are situated at the root of the tongue in front of the neck, we now have some insight. Most animals have this hyoid bone that anchors the tongue. The shape and complexity of the bone determine how free-moving the tongue can be. Scientists have discovered that nearly all dinosaurs had simple tongues that laid flat and were extremely similar to the tongues found inside the mouth of a crocodile today. Yeah, this crocodile. Go ahead and take a closer look. Nah, just kidding. Come on back. Let's take a look at some specific dinosaurs and start with the Brachiosaurus. Let me stick my neck out on the line by guessing that most of you will be familiar with this dinosaur because of its neck. You know, the one which was typically 30 feet in length. Despite its neck being its most distinctive feature, its name actually translates to arm lizard in Greek. It's common knowledge that the Brachiosaurus is one of the largest dinosaurs to ever have lived. On average, it reached 76 feet in length and 40 feet in height. It's roughly the length of 2 school buses and as high as a 4-story building. None of which were around in the era of the big guy here. Fragmentary leg bones and vertebra of even larger dinosaur species are known, but these skeletal remains are too incomplete to determine their exact size. So this guy may have been the largest dinosaur ever. A renowned herbivore, thank goodness. The Brachiosaurus is thought to have eaten up to 880 pounds of dry plant matter every day. Most of this was made up of coniferous trees, ginkgos, and cycads. This target might have been hard to hit for this dinosaur, as researchers have learned that its teeth were spoon-shaped and not ideal for chewing food. This means that the creature would have swallowed vegetation whole, as its teeth were suited to stripping it but not breaking up large chunks of plants. This, along with the dinosaur's body shape, suggests that the Brachiosaurus would have liked to feed as quickly as possible. Dinos like these didn't always make use of their ability to strip towering trees when dining. The Brachiosaurus traveled in herds, moving to the next location once they had exhausted all of the local vegetation. And I mean all of the local vegetation, not just that which hung high on trees. It's likely that the creatures supplemented their diets with vegetation at lower levels, especially after they'd done a number on all the nearby trees. This method of feasting was the most energetically appealing for this giant. By munching on lower vegetation, researchers believe that the dinosaurs saved up to 80% in energy compared to when foraging for high-up food sources. They have also discovered that the nostrils of a Brachiosaurus were on the front of its face and not the top. This is because we now know they roamed the fertile floodplains in their respective herds. For decades, it was believed that these creatures lived in deep, watery swamps. Let's look at another common misconception about a popular dinosaur. Please put your hands together for the Tyrannosaurus rex, which is arguably the most famous of all dinosaurs. Discoveries from the past 100 years have revealed that theropods had heavily feathered skin. Theropods are the family of dinosaurs to which the T-Rex belongs, so naturally, people began to think that the creature would have been covered in feathers as well. However, a study from 2017 took skin impressions from the iconic dinosaur and found no evidence of the structures required to support feathers. If a T-Rex did have feathers, they would have been limited to its back. Researchers accept that other large dinosaurs of the same family as the T-Rex have been discovered with their remains covered in feathers. An example of this would be the Yutyrannus dinosaur. But as of now, the accepted theory is that feathers weren't a common feature of T-Rexes. This makes it easier to believe that feathers were exclusive to smaller tyrannosaurids and were there as a means of keeping the creature warm. For a long period of time, researchers thought feathers were an exclusive feature of the theropod family. But this theory has been debunked. Just like the kid at camp who was kicked out of the top bunk. You know, debunked. Anyway, fossil evidence discovered in Siberia now suggests that multiple different family groups of dinosaurs had feathers. The Siberian fossils in question belong to another species of dinosaur, Calindrodromeus zebucolicus. Oh, you think I mispronounced that? Okay, prove it. Now, this dinosaur, I'll call her Calinda, had a pelvis structure superficially similar to that of a bird and was roughly 4.5 feet long, about as tall as a fridge. Since the purpose of feathers on dinosaurs was for warmth, it's quite possible that dinosaurs from cold weather climates had more feathers than their counterparts in warm weather climates. In general, bigger animals struggle less with keeping themselves cool, so it's likely that any of the large dinosaurs who lived in these warm climates had no feathers at all. Smaller dinosaurs who lived in cold climates, on the contrary, had plenty of feathers. We now even understand what some of the designs and patterns of these feathers on dinosaurs looked like, thanks to the discovery of an ornithomimus, complete with feather and skin impressions. The name of this dinosaur is derived from Greek and actually translates to bird mimic. They were typically 11.5 feet in length, nearly as tall as a giraffe, and despite being omnivorous, had no teeth. Its other distinctive features included 3 fingers, which were all unusually the same size and length. And despite their thin bone skulls, they also had large brain cavities. Their legs were extremely long, in particular their foot bones. Combine this with their toothless beaks and long necks, and yep, it must have looked a lot like an ostrich. Although they're not as big as the Brachiosaurus or dinosaurs in general, they are bigger than any other bird in the world. And it wasn't just the body limbs of an ornithomimus that made it resemble an ostrich. They also had very similar feather patterns. Their heads, necks, and lower legs were mostly bare of feathers, but the rest of their bodies were well coated in downy plumage. This is what you call a bird's layer of feathers as a whole. It's possible, like an ostrich, that the dinosaur would have used this unusual feather pattern to regulate its body temperature. Despite some dinosaurs possessing feathers like birds, on top of also being their distant relatives, dinosaurs didn't have the type of feathers required to fly for most of their existence. Feathers found in fossil impressions or preserved in amber have allowed researchers to gain insight into why these creatures weren't very aerodynamic. The structure of these feathers appears to be very simple, with a poorly defined and flexible central shaft. These feathers would have better served any dinosaur as a fashion statement, as they would have helped attract the attention of other dinosaurs. These feathers also would have had the ability to regulate body temperature. Surprised to hear that dinosaurs had ostrich-like feathers? Wait till I tell you that their prehistoric distant reptile cousins had something that looked like fur. Allow me to introduce you to the pterosaur. Its name is derived from Greek and translates to winged lizard. Just like dinosaurs, they were initially thought to have scaly or leathery skin all over their bodies. But over the course of the 20th century, fossil examinations revealed that many parts of a pterosaur's body were furry. The wingspan of a pterosaur could reach the length of over 23 feet, about as long as a London bus. Its toothless jaw was very long and resembled that of a pelican. How could something that looks like a pelican be so terrifying? These creatures were coated in pycnofibers. Those were simple structures, feather-like in composition, but strand-like and fuzzy like fur. Further research suggests that some parts of the pterosaur's body had more complex kinds of feathers with branching strands. If this is accurate, it would be the first time feathers were found on an animal that was neither a dinosaur nor a bird. Alright, check this out. Water boils faster when you add a bit of salt. Myth. It doesn't make any difference, and even if it does, it may take longer for the water to boil. But it might make your pasta taste better. Just saying. Bats are blind. Not true. The myth probably comes from the fact that they're nocturnal creatures and have extraordinary hearing abilities. They chase mostly when it's dark and rely on a thing called echolocation, but it doesn't mean they're blind. Their eyes aren't useless, they're just adjusted to low light conditions. A blue whale is so big, its tongue can weigh as much as a big elephant. True. Yep, these fellas are huge. You lose more heat through your head. Nah. The real reason why people believe it is because when it's cold, our head is the only part we're most likely to keep uncovered. If we went outside wearing just a t-shirt, we'd lose heat through our arms, not to mention legs, hips, and other parts. So, wear a hat, guys. tongue map says we have different parts for different tastes. Not really. There are individual taste buds that sense certain flavors more than they do with others, but it doesn't mean one area can taste sweet better than the other. Studies showed all mouth areas have taste buds sensitive to all tastes. Hey, check out this tongue map for the blue whale. Looks like she's partial to plankton. Dinosaurs were giant. Well, that's false. Movies show them as huge scaly lizards, but nope. First off, there were many smaller dinosaur species, and some of them were as small as a turkey or a pigeon. Plus, some dinos, like T-Rex, were even covered with feathers, especially at the early stages of their lives. Oxygen is colorless. Partially true. In gas form it has no color, but in solid or liquid form it has a sky blue shade. Chameleons change color because they want to match their surroundings. Myth. That would probably be a very tiring thing to do. In reality, some other things like mood, temperature, or the amount of light they get affect their color. When chameleons relax and stretch cells, crystals that are inside of them are affected by the light. These animals use crystals to communicate with each other. So, for example, darker shades show that they're not in such a good mood. It's more like they kind of feel aggressive. So I think I'll back off here. Neanderthals aren't our ancestors either, even though they lived with modern humans at the same time at one point, but mostly in different areas of our planet. So they're not just a stage of human development, but a different lineage. They were also pretty creative. They used fire, made tools, ate medicinal plants, cleaned their teeth, and so many more things similar to our species. Neanderthals probably went extinct because of harsh climate changes. Turkeys can blush. That one is true. They're just like us when it comes to this. When angry, excited, or even feeling bad, the skin on their necks and heads turns red, just like my big brother. Black holes are not really holes, as the name may imply. They are very dense objects with an extremely strong gravitational pull. Flamingos are such cool animals. True. They bend their legs at the knee. Myth. They actually bend them at the ankles, since the knees are closer to the body as well as covered in feathers. Supermarket apples are fresh. Maybe yes, but maybe not. They can be up to 1 year old, since they're often picked between August and November. After that, they're covered in wax and dried in hot air. Finally, they're sent into cold storage, and after 6 to 12 months, we see them on the supermarket shelves. Bottled water has an expiration date? True. But that doesn't mean the water is the thing that expires. The bottle does. The plastic starts to leak into the water, and some unwanted chemicals appear. The tea bag wasn't actually planned. True. In the early 20th century, Thomas Sullivan filled small silken bags with samples of tea leaves and sent them to his customers. The idea was to open them and toss tea leaves in the hot water. Many customers thought they were supposed to put those bags into the teapot without opening them. The tea bag went through some improvements, got string and a paper tag at the end, and the new unplanned invention was ready. Lightning will never strike the same spot twice. Not true. The Empire State Building was once struck 8 times in only 24 minutes. There was a terrible storm, and nothing could or can generally keep lightning away from the place that got hit. If a struck place has features that attracted the lightning in the first place, like terrain shape, standing water, or height, it may attract it once again. You have so much DNA in your body that you can actually stretch it from the Sun to Pluto and back. True. And not just once, 17 times. Of course, you're not going to look the same after you do that. Crocodiles are one of the oldest species in the world. Yup. They have been around for 200 million years already. Like my neighbors down the street. Opossums sleep while hanging by their tails. You can see that in cartoons and some photos, but in general, they don't. Their tails are really strong, so these animals can grip branches and hold their weight, but only for short periods. Adults are really too heavy to stay in this position for too long, so they wouldn't get much rest. Goldfish have a 3-second-long memory. Nope. Those colorful fish are actually really smart. One study showed goldfish could tell the difference between 2 classical songs. They're not quick learners, true, but after over 100 sessions, they did it, which wouldn't be possible if their memory could really last only for 3 seconds. One type of salamander, you can read that on your own, go ahead, can extend its tongue over half of its body length in only 7 milliseconds. True. That's 50 times faster than a blink of an eye. Ooh, gotta be fast to catch that tongue map. People can multitask. Not true. Checking emails, talking on the phone, cooking, It seems like doing several things at the same time saves time, but research shows multitasking is not quite possible. Our brain is wired to do one thing at a time. So when we think we're multitasking, it's actually switching tasks, which can take even longer rather than saving us some time, as well as whittling down our attention spans. Earth is not the only planet with water. NASA discovered Jupiter had an ocean with twice as much water as we have on our planet. It's right under a layer of ice. Even Mars has some liquid water flowing. Also, the Earth is round. Or is it? Technically, it has flattened poles, together with a bulge at the equator. That way, it has an irregular shape of an ellipsoid. Zombies are not made up. True. Okay, humans can't turn into ones as we see in movies, but the animal kingdom has its zombies. For instance, there's a type of fungus that takes over ants, spreading specific chemicals in their brains. That makes an ant leave its family looking for the place where this fungus wants to live. The world's biggest waterfall is under the ocean. Oh, very true. It's in the Nordic seas. The cold seawater is denser than the warm waterfall. The drop is almost 2 miles long. The smallest wasp in the world is not bigger than an amoeba. True. This wasp has the same body parts as other bugs, like eyes, wings, brain, legs, and more, but it's just 0.008 inches long, which, in most cases, makes it smaller than one-celled organisms we also know as amoebas. Snow can only be white. Not true. And I'm not talking about the snow near fire hydrants. For example, there are some mountains with pink snow, like the Sierra Nevada in California. Its color is caused by a certain type of algae living there. Aurora Borealis has a sister. True. It's called Aurora Australis, and you can see it in the southern hemisphere. The best time to see it is in winter. Over 99% of atoms is empty space. True. If we collected all the people in the world together and removed all the empty space between the atoms out of them, the population of Earth would fit into the size of an average orange. I think we should try that. Then I could finally get a seat on the bus. Dolphins communicate and call each other by names. True. They use specific vocal whistles to identify each other. So long, and thanks for all the fish. The toilet flushes in different directions when on different hemispheres. Nope. The direction is the same whether the toilet is in Australia or France. Really? A snail can have a pretty extended nap. True. Some snails can sleep for around 3 years in a row. Sharks smell just one tiny drop of blood from miles away. Not quite. Sure, their brain region in charge of smelling odors is enlarged, but the ocean is really big. Plus, it takes time for odor molecules to spread in liquid. On a pretty good day with favorable currents, a shark may smell the prey from a distance of a couple of football fields away, but not miles. Finally, penguins propose to their significant other. True. They're monogamous, and after choosing a mate, the male gives the female a pebble to show his affection. Ah. Now, dinosaurs ruled our planet for over 165 million years, and some walk on our planet even today. Well, at least some of their descendants. Our modern birds evolved from what used to be a scary group of meat-eating dinosaurs we know as theropods. It all started during the Mesozoic era, about 250 million years ago, when a group of creatures called dinosaurs roamed Earth. They didn't look like those dinos that might have come to your mind, like Brontosaurus or T-Rex, but that's the group dinosaurs evolved from. These creatures walked on all fours and were as big as house cats. They didn't look as friendly, though, considering they were more like weird lizards with long, thin limbs. As you'd expect, this group wasn't exactly at the top of the food chain, but they were really fast and agile, which helped them survive. Over time, they adapted and started walking upright, so their legs were under their bodies instead of out to their sides. And over time, dinosaurs started growing long tails and bigger leg muscles. Their necks became stronger to support the new position they were in, and they even got extra hip bones that helped them move faster and more efficiently. That's when dinosaurs came on the scene, somewhere between 240 and 230 million years ago. Their name comes from the word dinosauria, which means terrible lizard. The oldest dinosaur fossils belong to these fellas that lived in Argentina. This one is even older, but we're still not sure if it's a real dinosaur or its relative, dinosaur morph. Now, considering the size of their ancestors, dinosaurs weren't large at the beginning, more like dogs or horses. There weren't many species back then, so if you could go back to that time, you'd see a bunch of reptiles walking around on two legs. But as time went by, they adjusted to different environments, and we got more interesting groups. For example, small and fast predators, like this guy. They all fall into the category of archosaurs, a group that also includes pterosaurs. Yup, their name may not imply it, but these are not dinosaurs. As some dinosaur morphs evolved into dinosaurs, they got certain advantages, like arms. They could do much more thanks to that. Some could catch prey using their hands. Others could grasp branches. Now, the freedom they got by moving their arms later helped some of them evolve into birds and start flying. Dinosaurs were probably warm-blooded. It means they could stay active all the time. They didn't depend on the conditions around them like, for example, reptiles do. The latter are cold-blooded, and they have to rely on their surroundings to regulate their body temperature. Dinosaurs didn't rule the animal kingdom for the first tens of millions of years of their existence either. Crocs were at the top of the food chain back then. Then the Jurassic period hit, and new kinds of dinosaurs showed up, like those giant plant-eating dinosaurs, for example, sauropods. You know them, dinos with long tails and necks that could eat plants at different heights, such as Brachiosaurus. Allosaurus is another famous dino from that time you will probably recognize. Spikes on the tail, bony plates on the back, you know, good old Stegosaurus. The Jurassic period was that time when dinosaurs started to get bigger and bigger. Then the Cretaceous period came along, and finally these magnificent beasts reached the peak of their fame. That was the time when the mighty T-Rex took the throne and got to the top of the food chain. T-Rex probably lived around 28 years, but it reached adult size really fast. Now, it wasn't easy to survive back then. T-Rex falls into the category of tyrannosaurs, and scientists have found out those fellas were fierce even when they were at a pretty young age. They discovered a fossil of a teenage tyrannosaur that was 75 million years old, and it had two baby dinosaurs inside its stomach. They realized that when tyrannosaurs were at a young age, they went for small dinosaurs, such as these guys, their dino cousins. As they grew older, they started taking on bigger challenges, like those peaceful giant dinosaurs that like to hang out with their group and eat plants. But large predators weren't the only ones that would have made you shiver with fear. That was also the time when fast and smart creatures called velociraptors show up. They weren't some scaly dinosaurs that would catch their prey using those claws in the shape of sickles, like shown in the movies. Their bodies were covered in feathers, and they would grow up to 100 pounds, which is about the size of a wolf. And to bust one more myth, they didn't hunt in packs. Velociraptors probably prefer to hunt solo and use their claws not to slash their prey, but to clutch it. T-Rex and Velociraptor fall into the group called theropods. We mentioned them at the beginning, the creatures today's birds evolved from. But even though velociraptors were covered with feathers, they still couldn't fly. Their wishbones weren't shaped in a way to support flying, and their arms were too short. Maybe it was better that way because during the Cretaceous period, flying dinosaurs called pterodons were the ones that took over the skies. Things had been going really great for dinosaurs until one unfortunate day 66 million years ago when an asteroid hit our planet. It's not that the asteroid itself erased all the dinosaurs right away, but it caused changes in the environment, which made it way harder to survive. At that time, about 75% of animals living on our planet went extinct. The asteroid was really big. When it hit Earth, it created a giant crater in the Yucatan Peninsula and sent a lot of debris into the atmosphere, which blocked the sun right away. For months, dense clouds of dust blocked sunlight. Our home planet was darker and colder than before, which wasn't good for plants. Creatures that ate plants couldn't survive those changes either. So it all turned into a chain reaction when most of the ecosystem collapsed. When the dust finally cleared, all those greenhouse gases that had formed after the impact made temperatures go way higher than they had been in a really short period of time. All land animals that weighed more than 55 pounds were gone. But not everything disappeared. There were fewer plants, but they were less affected than animals, all because their pollen and seeds can survive really messed up conditions for a longer time. So, what we have today is basically the seeds we were left with back then. After the asteroid hit, flowering plants dominated our planet. All non-bird dinosaurs went extinct too. Some species survived as birds. At first, those brave survivors were small, but later, birds evolved to bigger sizes. Now, there's a study that says that if the asteroid had slammed into some other spot on Earth, the fate of many creatures and plants would have been very different. If the rock had fallen maybe a couple of minutes later, it would have hit deeper waters. Less rock would have vaporized and risen to block out the warmth and light coming from the sun. In that scenario, we'd probably still have dinosaurs around. For example, Triceratops was one of the last dinos that had nothing in common with birds. If the asteroid had missed our planet, we would see some of them still roaming around, but since evolution never rests, maybe in a little bit different form. Hundreds of dinosaur species roamed our planet, and researchers give a name to a new type approximately every 2 weeks. It's not fair to stick to T-Rex, Stegosaurus, Spinosaurus, and other famous sauruses all the time. They've had their chance to shine in the movies and across the internet. So let's check out dinosaurs that no one talks about. First on our list is Torosaurus. The special thing about this dinosaur is that it definitely had one of the largest skulls ever found. It was big because of this frill going from the back of the animal's skull and covering its neck. The frill wasn't there for protection. It was probably just to show off a bit. The bone in the frill was thin and full of holes. As you can see, it's very similar to Triceratops. There are still debates about whether these two are the same species, but more and more studies show that they were more like cousins. They were probably similar in size, but Torosaurus had a longer head with big openings, as well as longer frill bones with a groove on top. It also had more pairs of horns on the back of the frill. Some like to call Torosaurus a bull lizard. These fellows were plant eaters that may have lived in social groups. They existed at approximately the same age, but Torosaurus somehow ended up on the less popular side of the family. Kentrosaurus was a small stegosaurus. It's one of the least cuddly dinosaurs of all time. Its long, thin spikes seem to be a pretty good defense mechanism. Stegosaurus, on the other hand, had shorter, thicker spikes that were less likely to bend or snap when the animal used them. Now, you wouldn't want to get anywhere near Kentrosaurus, though. Its tail could swing in a big half circle and hit with a force strong enough to break a human skull. Any volunteers? No? Okay. One scientist used scans of the dino's fossils to make a computer model of its skeleton. The model showed that Kentrosaurus had a flexible neck. It must have been really useful for looking around to see if something interesting was going on or if there was any dangerous animals trying to sneak up. Kentrosaurus typically walked on all four legs with straight hind limbs. The computer model tells us it could spread its front legs out to its sides, too. Maybe it was a way to protect its belly during fights. Stegosauruses, in general, had tails that were like big weights at the back of their bodies. That's why their balance point was closer to their hips. That's also the reason why they could easily stand on their hind legs and swing their tails around. So most people haven't heard of heterodontosaurs, even though their fossils show that dinosaurs got feathers way back before we thought and in groups where we didn't expect it. In 2008, paleontologists identified the first known skull of a baby Heterodontosaurus, which was less than 2 inches long, smaller than a tea bag. This baby dinosaur had relatively big eyes and a short snout compared to bigger ones of its kind. Now, what's really interesting is that some scientists used to think that Heterodontosaurus's tusks, like those of modern warthogs, only appeared when they were fully grown. But it seems they had them from the early stages of their life. Heterodontosaurs had 5 fingers on each hand, 2 of which were opposable. It was a good tool, considering the animal probably ate both plants and meat. Humans have different types of teeth, some for biting, some for chewing, and also canines. But most reptiles have just one kind of teeth. Heterodontosaurus was special because it had 3 different types of teeth: small peg-like ones, big teeth resembling canines, and square-shaped teeth that did the cutting job. Scientists are not entirely sure how this creature used these different types of teeth. Maybe it was for digging up roots, breaking into termite nests, or even defending themselves against dangerous animals. Okay, say this name with me now: Psittacosaurus. She was quite a common dinosaur in its time, but she never still gained popularity. Scientists found out that when these dinosaurs were young, they probably crawled, considering they had longer arms and short legs. But as they got older, between 4 and 6 years old, their hind legs started growing much faster and became much longer than their front legs. So, later in life, they likely didn't move on all 4s anymore, but walked on 2 legs. Inside the stomach of one of these creatures, scientists found pebbles. This shows the animals either had a hard time digesting what it ate, or it didn't chew its food very well. Its beak looks quite familiar. That's how it got its specific name, a parrot lizard. It was really strong, and some believe the creature used it to crack and open tough nuts and seeds before the pebbles in its stomach helped mash them up for digestion. These guys might have been good at swimming. They had broad feet, and the shape of their tail could have helped them move in the water relatively easily. Some scientists even believe they might have spent most of their lives swimming in rivers and lakes. In 2004, researchers found something really sweet: 24 young parrot lizards huddled together. They were too big to be hatchlings, so it could be a bunch of teenagers who had left their nests and then formed a group where they could support one another and defend themselves better. But apparently, that plan didn't work out so well. Now, check this one out: Stygimoloch, or as they call it, Styx demon. We're looking at a peaceful plant-eating creature with bony spikes and knobs on its skull. Most scientists believe it was a younger form of this fellow, even though they used to think they were a separate species. Stygimoloch is smaller than its more popular cousin, but it's also more robust and has a pretty thick neck. This dinosaur, with small forelimbs and long hind legs 3 feet high, which is half as high as an average human. That doesn't sound dangerous in the world of giant and fierce dinosaurs, but the animal had a very thick skull roof. Maybe it wasn't the strongest tool to defend itself, but it probably helped in combat with rivals from its own species. They most likely headbutted to win the hearts of their chosen ones. But rivals from its own herd were a piece of cake compared to the predators that might have gone after it. After all, this dino lived at the same time as old T-Rex. Now, when someone tells you to picture a dinosaur, Chicxulub would probably be the last thing coming to your mind. It looks as if you've put together pieces of random animals and tried to make your friends believe this truly was a real animal that once roamed the earth. But it's actually a dino, with giant sharp claws on its forelimbs, a bulky body, and a long neck ending with a tiny head. Now, don't let the claws scare you though. These creatures didn't go after other animals since they were herbivores, but these claws could protect the animal from intruders and predators. The full scientific name of this creature describes it as a giant sloth-like reptile from China. This animal was one of the biggest and oldest members of the group where it belonged, which lived around 115 million years ago. No, I wasn't around then. At first, it was hard to tell which animals were related to this weird-looking dinosaur. But in the 1990s, scientists made a conclusion that they were modified plant-eating theropods, which is similar to carnivorous dinos. They also most likely had feathers and small wings, like some sort of a very big turkey.
So we're moving to 66 million years ago, in the world where dinosaurs lived. What are we doing here? We're just watching these giant reptiles and waiting for one of the most massive disasters on our planet to strike. Right now, a giant asteroid bigger than Mount Everest is flying at a tremendous speed, exceeding the speed of sound 40 times in the direction of our planet from the depths of space. It passes through our atmosphere, heats up, and hits the coastal part of the island of Yucatan, which separates the Gulf of Mexico from the Caribbean Sea. The enormous release of energy destroys all living things in the area, on land and in the ocean. The air over the island is filled with smoke and ash. Yucatan Island has taken the brunt of the blow. The blast wave instantly turns the green territory into a giant, lifeless crater. The asteroid fell at the wrong time. By the moment of the catastrophe, Earth had already been undergoing devastating changes. Continents were separating from one another, and some volcanoes were waking up, pouring lava onto the ground. Dinosaurs had been almost on the edge of extinction, but the asteroid shaped their fate. Now, Yucatan looks like a giant funnel of melting rock. There are no more dinosaurs here. But what about those animals that were far from the crash site? The noise from the explosion was so loud that pterodactyls hanging out far from the crater flew up into the sky in fear. A Tyrannosaurus got distracted from its hunting and ran away as far as possible, along with Triceratops. But somewhere, even further, in mainland Mexico, ancient lizards continued to chew grass and run around fields. They did notice a bright flash, but didn't mind it. They didn't even hear the sound of the explosion because the sound wave dissipated in the air. No blast wave, no earthquake, and no meteor shower. Dinosaurs continue with their lives. Unfortunately, not for long. Most dinosaurs would have survived if the meteorite had fallen in a field, ocean, or any other place. Perhaps today, you would see them in nature reserves, but the meteorite fell in the most unfavorable place. According to studies, the giant rock had a 1 in 10 chance to destroy dinosaurs, and it took this chance. It wasn't a soft landing. The stone didn't slip on the ground, but hit the rocky terrain like a giant hammer. The catastrophe wasn't limited to a blast wave and a crater. The asteroid fell into large stalks of flammable materials. Simply put, the space rock got into a giant vat of combustible substances. This provoked a drop of millions of tons of soot and ash into the air. The fire quickly spread throughout the island, emitting black smoke into the sky. Dinosaurs living hundreds of miles away from the site are getting nervous. Feelings of anxiety are growing. Their inner instinct of self-preservation signals that disaster is coming. The sky becomes gray and darkens. Black clouds cover the sun and reflect the light. However, these are not just regular clouds, but volcanic ash. The asteroid fell at the most destructive angle. It also hit the coastal part, so the destruction reached the seabed filled with sulfuric acid. And now it's all coming out. Toxic fumes get mixed with incandescent ash, soot, and metals the meteorite contained. A fiery hot cloud emits acidic smoke that is very harmful to health. And this cloud, driven by the winds, grows and stretches all over the continent. It's getting cold on the ground. Plants, grass, and trees are quickly withering. The green valley, saturated with life, becomes gray and lifeless, which leads to an imbalance in nature. Most dinosaurs can't get fresh grass and leaves. This problem also affects predatory reptiles since the number of herbivorous lizards significantly decreases. Animals start to freeze and starve. They move away to search for some food and find a warm place. But it's too late, because a poisonous firestorm is approaching them quickly. Dinosaurs try to hide in burrows and caves. Some lizards are looking at the sky, which is getting darker each second. A tiny sparkle slowly falls from a black, fiery cloud. This is a particle of hot ash. It drops to the ground, touches the dry leaves, and sets them on fire. Millions of such particles fall to the ground. The forest flares up like a match. The smoke from the burning trees rises and becomes part of the expanding ash cloud. The more the fire spreads, the larger the ash cloud becomes. Sulfuric acid vapors mix with molten metal particles and fall to the ground as poisonous droplets. Acid rain corrodes vegetation and poisons the soil. Flying lizards rise into the sky and enter the center of the firestorm. Dinosaurs on the ground are running from the forest towards the water, but it's impossible to escape from the apocalypse. The scale of the disaster is increasing exponentially. While acid rain and firestorms destroy one part of the continent, the coastal side faces another problem. The fall of the meteorite caused a giant tsunami. It hits the shore and floods large areas of land. After the massive explosion, the first wave forms. It could quickly destroy modern-day New York. A series of smaller waves, the size of a 5-story building, sweep across the Atlantic Ocean and the North Pacific Ocean. Giant tsunamis are not so scary for deep-sea dinosaurs, but the poisonous cloud poses a danger to them. Particles of sulfur and ash cover the sky above the water surface and bring down poisonous rain. Seaweed and phytoplankton don't survive it. Thus, millions of fish face the threat of famine. This causes huge problems for the whole food chain in the ocean. Giant sea lizards can't survive either. The meteorite created a domino effect that put the entire continent under threat of extinction. A few weeks have passed. The ashes have settled and cooled down. The fires are over, and the air has become cleaner. The sun is finally peeking through the clouds. But the planet looks different now. Giant lizards don't exist on the planet anymore. Green forests have turned into gray fields. Fortunately, not for long. The seeds of plants and trees have survived the apocalypse and are now blooming with renewed vigor. Nature is filled with colors again. Little creatures similar to rats have been hiding in the ground and have also survived. And now they finally get out to continue spreading life. It wasn't firestorms, tsunamis, fires, and lack of sunlight that destroyed the dinosaurs. The primary damage to the world at that moment was the disruption of the food chain. All big herbivorous dinosaurs and giant toothy monsters lost their food sources. Small animals and some flying dinosaurs survived to further evolve into modern birds and mammals. Large animals, the size of a rhinoceros, appeared 15 million years after the disaster. Tens of millions of years passed since that moment, and then humanity appeared. Thanks to modern technology, we've discovered the reasons for the destruction of dinosaurs. We don't know every detail, but we have a common picture of those events. And the scariest thing is that if the same asteroid fell again into some explosive terrain, we wouldn't be able to do anything about it, and our remarkable technologies wouldn't help much. Yes, we might disperse ash clouds and extinguish some fires, but it would be insignificant. Floods, fires, and acid rain would make life in big cities unbearable. The only thing that would help us survive could be underground bunkers and other reliable shelters. But how to survive the famine that would come after the destruction of vegetation and crops? We are developing and improving technologies that can protect us from asteroids, like lasers or space rockets with explosives. But even if we destroy one big rock, it might tear into a million pieces. Some will burn up in the atmosphere, and some will fall on the planet in the form of a meteor shower. Anyway, we'll face huge natural disasters. Therefore, all we can do now is hope that no rock from space will come to us.
Boom! An explosion of supersonic waves, interplanetary heat, dust, fumes. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. A few seconds ago, this rock, weighing trillions of tons, was hurtling towards Earth. It could fly from New York to Anchorage faster than you could fry yourself an omelet. This monster's name? The Chicxulub incident. Epic name, right? 66 million years ago, it crashed into the Earth. Back then, dinosaurs ruled the planet, but not for long. The epic collision took place in modern Mexico, in the Yucatan Peninsula, right near Cancun, where the dinosaurs were vacationing. Well, probably not. Still, the huge space rock hit the ocean, But even all that water couldn't stop the inevitable. The collision caused a huge amount of energy to be released. The horror on a planetary scale had begun. Imagine a mini-sun lighting up the surface of the Earth with tsunamis the height of the Statue of Liberty bursting from the epicenter of the watery impact. Not good. The blast blew through the surface of the Earth. It was as hot as an oven and burnt everything in its path. The impact provoked a colossal earthquake and serious volcanic activity. A bunch of volcanoes simultaneously released hot lava and ash into the prehistoric skies. Millions of tons of ash and soot poisoned the air. This formed a huge ash cloud in the atmosphere, which blocked out the sun's rays for several years. The long winter had begun. Only there wasn't any snow falling from the sky, but rain made of sulfuric acid. Yes, the Chicxulub incident might just be the most important thing that ever happened in the history of our planet. Even more than YouTube. Back then, there were loads of volcanic eruptions, a lot of flammable oxygen in the atmosphere, constant temperature changes. It was the perfect and worst time for all of this to go down. So, how are we so sure about all this? Well, the asteroid left an absolutely huge crater on the planet's surface. Today, this scar is hidden under the Gulf of Mexico. Scientists found a lot of places on Earth with abnormally high levels of iridium. This metal is very rare on Earth, but it's in a lot of asteroids that scientists have examined. Scientists studied some 66 million-year-old rocks. In the layers of rock, they found dust, the same dust that comes from asteroids. This could only have happened if a huge asteroid had crashed into Earth. The catastrophe led to the extinction of not only the dinosaurs, but also the asteroid. It was so hot at the point of impact, part of the asteroid just disappeared. A lot of water vapor and carbon dioxide shot up into the atmosphere. But the biggest problem, sulfur. It got kicked up by the asteroid impact and flew up into the air. These tiny sulfur particles blocked out a lot of the sun's rays. Without the sun, a lot of plants disappeared and the climate eventually got colder. The immense heat turned stones into glass. Scientists call these things tektites. The energy of the impact threw them up into the skies. After a short flight, the tektites fell down to Earth. But it wasn't pretty. Rain fell too, only instead of drops of water, you'd have seen hot glassy fireballs. They bombarded the planet's surface for days. The tektites set fire to everything. Scientists found evidence of this all over the world, not just near the collision site. But a lot of things from back then are still a mystery. Some scientists think that Chicxulub wasn't even an asteroid. It might have been a comet. Asteroids are mostly made of stone and metal. Most often they kind of look like a potato. A comet contains rock, metal, and ice. Comets look like dirty cosmic snowflakes, complete with ammonia, methane, and carbon dioxide. Comets sometimes come from the Oort cloud. It's a huge cloud of ice and debris around our solar system. From time to time, comets break free from the pack and head towards our sun. According to scientists, this special comet flew right past Jupiter. The gravity of that huge planet accelerated the comet even more. It flew towards the sun, gaining more and more speed. The comet's outer ice shield started to evaporate, and it probably gave off a lot of dust and gas, which made it look like it had a tail. The sun's gravity eventually shattered the comet apart. One of the fragments flew through space and crashed into the Earth 66 million years ago. So, asteroid or comet? The truth is, we'll never know. What we do know is that the Earth was seriously unlucky to be in its path, and it was never the same again. The catastrophe stopped the development of 75% of life on Earth. Some bigger marine animals, like crocodiles, turtles, and fish, survived the impact. Out of all land animals, the only ones to survive were the ones that were, on average, smaller than the modern raccoon. That includes a bunch of special species of dinosaurs, the ancient ancestors of birds. Scientists believe they survived for two reasons. After the huge impact, it took a long time for plants to start growing again, and a lot of animals didn't survive. Most remaining animals didn't have enough food. But these dinosaurs had a beak. With its help, They could split open nuts and dig seeds out of the soil, so they survived. The second reason is that these lucky guys had bigger brains. Some people think that they were able to cooperate with each other and quickly adapt to the new conditions. Other life forms survived too. Fungi and mold survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape. After a few thousand years, forests started to reappear. The animals that survived were pretty much all inconspicuous and small creatures. They lived in burrows, safe from all that hot ash. Before the collision, mammals had lived in the shadow of dinosaurs. But with all the dinosaurs suddenly gone, things were about to change. Mammals were able to take over. They began to dominate life, at least on land. Back to the moment when everything changed. Turns out, it wasn't the size of the asteroid that made it so powerful. It was more about the angle in which it hit the Earth. If the angle of impact had been different, the dinosaurs might have even survived the catastrophe. So, what would that have looked like? Well, let's travel back, way back. Oh no, there's a giant asteroid heading for Earth. Oh, wait, never mind, it missed. Whew. There are plenty of earthquakes, tsunamis, and volcanic eruptions every day, but dinosaurs don't mind that much. No big deal. Fast forward a few million years, and most of these ancient lizards have changed and are now unrecognizable. Thanks to a couple of ice ages, many dinosaurs are now totally covered with feathers to protect them from the cold. Mammals exist, but they're few and far between. You see a lot of bats in caves. There are tons of rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, no elephants, or other large mammals. Why become large and eatable when there are so many dangerous reptiles with huge fangs around? There are no whales in the sea. Parrots, hawks, and pigeons are nowhere to be seen. But pterodactyls 2.0 whiz past you constantly. Some are about the size of a helicopter, while others are no larger than a swan. There are plenty of primates, but they're in no hurry to climb down from their trees and walk on two legs. No venturing out into the savannah, no evolution into Homo sapiens. In this alternate reality, open spaces are very dangerous. But then again, so are forests and trees. Nowhere is safe. To get some delicious primate treats, many smaller dinosaurs learned to climb trees. This was already happening back in the Cretaceous period, right before that huge asteroid just missed Earth. Whew, that would have been an epic collision. Dinosaurs have grown wiser since that near miss. Some are even as smart as a modern chicken. A large brain uses a lot of energy, and that's not always a good strategy for survival. Safer to keep brains small and keep making those teeth bigger and pointier. From tiny critters to colossal creatures, all animals are trying to escape from a wall of fire moving in their direction. The temperature is rising, and everything around starts catching fire. Soon, lots of animals and plants on Earth will cease to exist. This is the aftermath of a giant asteroid crashing into our planet. But what if dinosaurs had had critical thinking skills? They could have guessed what was going to happen, because this asteroid was visible a year before the impact. 1 year before the impact. With no city lights, all bright spots in the sky are stars. Some of them are planets reflecting the light coming from the sun, like Mars. But one of these dots is the asteroid. Later, it's going to be known as Chicxulub impactor. It got this name because of the region of modern-day Mexico where it fell. Anyway, at this point, the asteroid looks like a star. It has the same brightness as Neptune. You could even have photographed it with a high-quality camera. If only dinosaurs had thumbs. The impactor is now passing through Jupiter's orbit. From this distance, Earth looks like a pale blue dot. 1 month before impact. The asteroid has become much brighter. It's now the most brilliant spot in the night sky after the Moon. The asteroid crosses the orbit of Mars. Its tail, consisting of dust and gas, is getting longer and longer. It's now as long as 2 times the distance from Earth to the Moon. 1 week before the impact. The intruder's tail is now 5 times the distance from the Earth to the Moon, but the dinosaurs can't appreciate its beauty. To them, it's just another bright dot in the night sky. If this asteroid were flying toward Earth right now, scientists could pinpoint the exact location of its impact within a mile. Then we would evacuate people from the impact area and avoid a major catastrophe. 1 day before the impact. The Chicxulub impactor now holds first place among the brightest objects in the sky. The light surrounding it, called a halo, seems even bigger than the Moon itself. The asteroid is now passing through the Moon's orbit. It looks like a bright spot that leaves an ashy trail behind it. 1 hour before the impact. The light from the Chicxulub impactor is brighter than the full Moon, and its movement can be seen with the unaided eye. Nights on Earth aren't dark anymore. Only now, dinosaurs begin to feel anxious. All animals on Earth start to seek shelter. 10 minutes before the impact. The asteroid is now passing through Earth's orbit. Thousands of small fragments from its tail begin to fall on the planet. It looks like a meteor shower. So far, these fragments are too small. They all burn up in the atmosphere before reaching the surface of the planet. The asteroid is approaching South America. If someone was looking at it from Europe, it looked like a sunset. The bright dot of the Chicxulub impactor is falling behind the horizon. 2 minutes before the impact. Dinosaurs can now easily see the asteroid's shape. If they knew how to do it, they could even estimate its size. It's a bit more than 6 miles across, which means it's almost the size of Manhattan Island, and the giant's weight is 15 plus 15 zeros pounds. It's flying toward the Yucatan Peninsula at a mind-boggling 7.5 miles per second. At that speed, you could get from New York to Los Angeles in around 10 minutes, but you'd kind of burn up on the way. 10 seconds before the impact. The Chicxulub impactor is now approaching the ground. A few more feet and bam! The night sky suddenly turns white. The flash is so bright that the sun isn't visible at this point. The asteroid's entry causes a powerful blast that can be heard on the other side of the world. The huge asteroid begins to burn because of friction with the air. It heats up and splits into many pieces. These pieces shower on Earth. After a few seconds, the largest part of the meteorite hits the ground. Its mass and speed provide the Chicxulub impactor with an enormous amount of energy. In the next moment, a super powerful explosion shakes the ground. The blast wave from the meteorite begins to spread out from the impact site. It rips out huge chunks of soil and trees and then pushes them to the ground like dominoes. The temperature of the blast wave is so high that everything around the impact site catches fire. The energy released during the collision also penetrates deep into the planet. This causes the strongest earthquakes in our planet's history. They, in turn, generate tsunami waves as high as the Empire State Building. 5 minutes after the impact. The meteorite leaves behind a huge crater. It's as wide as Lake Huron and deep enough to fit inside 2.5 Mount Everests. Dinosaurs are running around in panic. They try to evacuate toward North America, but most of them don't make it through unfamiliar swampy territories. Another danger is the ongoing meteor shower. Hundreds of tons of ash and debris rise into the air. Heated up by high temperatures, they fall to Earth in the form of liquid lava. Ash and smoke fill the atmosphere and block the sun's rays. Earth plunges into darkness. For several more weeks, our planet will be totally dark. Acid rains will fall on its surface non-stop. There was a lot of sulfur in underground deposits on the Yucatan Peninsula. The energy of the explosion evaporated all this sulfur. Now it's cooling in the air, gathering in clouds, and dripping to the ground. Most animals survive the impact, but the mass extinction continues for many more months. The collision has plunged Earth into darkness, and this has wiped out most of the plants that fed on sunlight. The plant-eating dinosaurs have lost their main food source and begin to disappear. But plant-eating dinosaurs are the main diet of meat-eaters, and now dinosaurs like T-Rex have nothing to eat. Soon they go extinct too. In other words, it wasn't a meteorite that wiped out dinosaurs, but hunger and climate change. Meteorites of this size fall once every 100 million years. It means that such an event might happen again. Will humans manage to survive this disaster? These days, we can look out far into space, and the appearance of an asteroid the size of the Chicxulub impactor won't be a surprise to astronomers. In general, asteroids that are more than 460 feet across are considered potentially dangerous. Anyway, if we know about the approaching space body, we'll be able to build shelters filled with food and water supplies. Once the asteroid is close enough, we can wait for the impact and its consequences inside. But when people come back to the surface, they'll see cities and towns torn down. Our planet will look like a lifeless desert. That's why we need another alternative, which is to prevent the impact. Here, we have many options depending on the size and material of the asteroid. According to NASA, the most effective way is a kinetic ram. We'll need to send a fairly large and heavy object, such as a spaceship, into space. When it approaches the asteroid, scientists will choose the perfect trajectory, and the ship will crash into the space body. A powerful collision will change the asteroid's course, making it fly past Earth. The further this space body is from our planet, the easier it'll be to send it away. Another option is a controlled explosion on the surface of the asteroid. Newton's first law of motion will help us here. It says if a body is moving at a constant speed in a straight line, it will keep moving that way unless it is acted upon by a force. So, if we make a big enough explosion, or force, the asteroid will shift its trajectory. How much it moves depends on the amount of force applied to it. We can also blast the asteroid right from inside. In this case, there will be no need to change its trajectory. Instead, we'll try to turn one huge hunk of rock into a bunch of smaller fragments. They will burn up in the atmosphere and do no harm to our planet. Another way is a gravity tug. Every heavy object has its own gravitational force and gravitational field. Our goal will be to send a spacecraft to the asteroid and make it fly close to the intruder. The asteroid will attract the spaceship, but its engines will resist. As a result, the ship will slowly but surely pull the asteroid toward itself. This method will take much longer, but gradually, the trajectory of the asteroid will change and it won't crash into Earth. Hopefully. We can also use solar power. We can build a spaceship with a system of giant magnifying lenses. Then we'll send that station closer to the Sun. When we spot an asteroid, we'll point the lens in its direction and focus the beam on the space body. The heat from the Sun will cause the asteroid's material to evaporate. Eventually, this will make the intruder change its trajectory. Traveling back in time now, this used to be hard. We fly past the Middle Ages, the first human civilization, the ancient ancestors of the first humans, the dinosaurs, the first land animals, the ancient sea creatures, and so on to the very beginning of all time. And there it is! This nebula is our solar system. Right now, it's just a cloud of multicolored dust made of hydrogen and helium spinning around. This cloud has begun to shrink and become denser. There's a theory that there were supernova explosions near our nebula. Their shockwaves squeezed the nebula from different sides until the center of the cloud became too heavy. The enormous weight presses it, and nuclear chain reactions begin at the very center of this cloud. It heats the cloud and makes it glow. Soon it forms into a dense sphere, and that's how our Sun is born. It happened about 4.5 billion years ago. Our planet doesn't exist yet. There's only a disk of dust and space debris orbiting the young Sun. These pieces of debris are fusing gradually and getting heavier and heavier. Let's look at the very center of this pile of asteroids. The total weight of the debris compresses the central region so much that a dense metallic core is forming there. The enormous pressure heats the core, and the temperature at the center of the young Earth reaches nearly 10,800 degrees. And there's a liquid core around the solid one. It creates the magnetic field of our planet. Now, when radiation from the Sun and the solar wind reaches Earth, it smashes into a shield in the form of our magnetic field. So far, our planet is burning and looks more like a ball of lava. But it begins to cool down, forming a solid crust. At this point, another protoplanet appears on the horizon. It looks more like an asteroid, the size of Mars, and this massive piece of debris flies towards us. It hits the young Earth at such an angle that it knocks a part of our planet outward. The debris itself breaks into several pieces and stops in our orbit. After a while, all of this debris comes together to form the Moon. As a result of this collision, the Earth began rotating too fast. A day now lasts about 5 hours instead of the usual 24. But the Moon is heavy enough to slow our planet's rotation with gravity. Now, the Earth doesn't look like a hospitable place. The gravitational forces of the Moon are penetrating deep into the Earth and causing more volcanic activity. Also, meteorites are constantly falling here, causing frequent explosions on the surface. Ow! The gas that comes out of the volcanoes forms our atmosphere. The ice that was brought to our planet on meteorites evaporates. The vapor rises and turns into rain. This rainwater falls to the surface, cooling the hot lava and forming the first lakes and rivers. For several hundred million more years, Earth resembles the surface of Venus. It's a lifeless place with a bunch of volcanoes, acid rains, and no oxygen to breathe. The sun wasn't as bright as it is now. Plus, the sun's rays could barely pass through tons of volcanic dust in the atmosphere. But about 3.5 billion years ago, the first life appears here in the form of single-celled organisms that didn't need oxygen. They appeared in the shallow, warm parts of the ocean near the shore. These bacteria reigned on Earth for nearly 2 billion years throughout the Archean eon. They left stromatolites. These are stone pillars at the bottom of shallow, warm water. They're the product of simple organisms and bacteria. These bacteria evolved until they learned photosynthesis. Bacteria began to produce oxygen by absorbing the energy of sunlight. At first, this oxygen was spent on oxidizing rocks, but then excess oxygen began to fill the atmosphere. Plus, at this time, the first algae appeared, which also produced oxygen. This event is called the Great Oxidation Event, good name, which caused almost all living organisms to disappear from the face of the Earth. For simple organisms, oxygen was toxic, and the remains of bacteria and microorganisms sank to the bottom of the ocean. Many millions of years later, these remains will be recycled, and under the tremendous pressure of water and the Earth's crust, they will turn into oil. The Archean eon ended with this catastrophe about 2.5 billion years ago. At the same time, continents were forming on Earth, which would later drift through the world's oceans like puzzles and form a supercontinent. But for now, methane and carbon dioxide still make up most of the atmosphere. They cause the greenhouse effect and the rising temperatures on Earth. But the emergence of oxygen stops the greenhouse effect, and the temperature on our planet drops. An ice age, the so-called Huronian glaciation, which lasted from 2.4 to 2.1 billion years ago, begins. Scientists speculate that our planet was almost completely covered in ice at that time, even on the hot equator. A huge change when you consider that 2 billion years ago, our planet was like a ball and lava, but now it's like a block of ice. Earth, during the Huronian glaciation, was more like Jupiter's satellite Europa. There, too, is a thick crust of ice, under which there's a liquid ocean heated by the core. The evolution of the Sun saved our planet. Since its birth 4.5 billion years ago, it's been getting bigger and hotter. So, after 300 million years of an ice age, the Earth began to warm up. But almost all life there had been wiped out, and evolution has to start all over again. About 1 billion years ago, all of the continents of our planet were assembled into one hypothesized supercontinent, Rodinia, and all the oceans made up one colossal ocean of Miravia. 750 million years ago, that continent broke apart and huge chunks of land began drifting across the planet. Complex plants and multicellular organisms appeared just at this time. Algae, sponges, and fungi weren't the only inhabitants of the ocean. This is Sprigina. They're a kind of worms the size of a human finger. We have remains of these animals that are at least about 550 million years old. 541 million years ago, the Phanerozoic eon began. The main event at that time is the Cambrian explosion. Life began to blossom on Earth, and a great variety of living organisms appeared. Mollusks and echinoderms like starfish and sea urchins appeared. Living organisms evolved, having not only an internal but also an external skeleton, like trilobites. Some of these things could reach nearly 3 feet in length. Their protective shells suggest that there were predators in the ocean. A food chain started forming at that time. At the same moment, the drifting continents fused again. This supercontinent has a different shape and is called Pannotia. Later, these continents drifted apart again and began to collide with each other. This led to the formation of mountain ranges. Then the continents met for the last time and formed the giant supercontinent Pangaea about 335 million years ago. Here we can already see the outline of the modern continents of Africa, North and South America, Australia, and Eurasia. One of the largest sea creatures ever, the Dunkleosaurus, appeared. Some individuals could be as long as a school bus and weigh as much as a large SUV. The land had a hot and humid climate. It encouraged ferns and other plants to grow faster. Some of them could reach the height of a 3-story building, And for the first time in Earth's history, some animals leave the ocean and go on lands, such as L. generpeton and Ichthyostega. Anyway, at first, they live only on the coast because their skin wasn't adapted to the constant sunlight. In addition, they experience breathing problems. The first animals on land had both gills and lungs, but the lungs were underdeveloped, so they had to return to the water. Millions of years later, these animals evolved into more advanced amphibians. Though they were no bigger than ordinary lizards, they could already live fully on land. But this blossoming of life ended in a new ice age. Glaciers from the poles slowly crept toward the equator. Animals weren't prepared for this, and most of them didn't survive this extinction event. But 290 million years ago, evolution retook hold and more evolved land animals began to appear. Gradually, they increased in size, multiplied, and gave birth to a new species like Scutosaurus and Gorgonopsis. But this period didn't last long either. Only 40 million years later, as a result of unknown events, 95% of all living organisms on Earth ceased to exist. It could have been caused by a giant meteorite or by increased volcanic activity. Also, one hypothesis says it could have been the release of methane from the bottom of the ocean. The Mesozoic era began after this extinction. This is where the dinosaurs, as we know them, appeared and started a new page in Earth's history.
You're picking some veggies in the garden when you come across something big and round. It's covered in soil. When you dig it out, you find out it's a giant egg, bigger than one of an ostrich. But you don't have any chickens or ducks. And even if you did, none of those animals could lay an egg of that size. You pick it up. It seems real. You take the egg inside and build an incubator for it. A couple of days pass, but nothing. You go on with your life and forget about the egg's existence. You've been working in your garden all day long. All you want now is to get into a tub filled with hot water and have some dinner later. But while you're eating, you hear some noise coming out of the room with the incubator. You ignore it, thinking it's just some mice scampering around. But then the sound intensifies. You head there and see the eggshell cracking. In a couple of minutes, something begins to crawl out. You grab your phone and immediately start filming it. A tiny reptile pokes out of the now broken egg and starts examining its surroundings. You're shocked. You place your phone on a special platform to keep filming the creature. Meanwhile, you grab your laptop and begin researching what animal it could be. The creature doesn't have the snout of an alligator, nor does it look like a Komodo dragon. You go back to your dinner and feed the reptile some leftover meatloaf. It gulps the food down in a flash. The next day, you build a small terrarium to keep an eye on your new pet. Over the following weeks, you record every second of its life. You call the reptile Buster. The creature has already grown to the size of a dog. It runs fast and jumps pretty high too. You think it might be some new reptile species, but it doesn't crawl like an alligator or a lizard. Your pet has 2 tiny arms and large legs. Its jaws are massive for an animal its size. The reptile also has razor-sharp teeth. Your friend comes over for a movie. At one point, your reptile runs into the living room and starts biting the furniture. Your friend freaks out and starts yelling, "Dinosaur!" You calm him down and take the dino to the garage. You explain to your friend how you found the animal, and he tells you to contact someone to examine it. The next day, you take Buster to the vet and take a seat in the waiting room. You keep your pet in a cage so that no one can see it. But the dino starts growling in a strange way. Many people grab their pets and move away from you. It's finally your turn. You bring Buster in and show it to the veterinarian. The man looks shocked. He puts the creature on a metal examination table and starts looking closely at its features. Sharp teeth and claws, scaly skin. The vet tells you you've been raising a T-Rex for 3 weeks. He calls in other specialists to examine the animal. The next thing you know, you're in a lab with a bunch of scientists studying Buster. You sit there anxiously as they collect its DNA samples. They even ask for the footage you've been recording. After a couple of hours, they come back and tell you that you indeed have a dinosaur. They'll have to keep Buster in the lab to conduct further studies. So you go home, feeling a bit lonely. A couple of years pass. Now you have a degree in paleontology, specializing in T-Rexes. You've been working with the lab and monitoring Buster that has turned into a fully grown dino. You also teach at the university and have published a book called My T-Rex Buster. It has become a bestseller. One day, you come back from the university and turn on the TV. That's when you hear breaking news. A large creature has broken out of a lab outside the city. It's now on the loose. They show several images of the beast's footprints that lead to the forest. You get a call from the lab. They ask you to head down there as fast as you can. The researchers tell you what's happened and ask you to accompany them to the forest to find the dino. You put on a special protective suit and get into a jeep. After a couple of hours, you arrive at the spot where Buster was last seen. You get out and try to follow its footprints, but the rain has removed the marks the creature left almost completely. The scientists check the tracking device placed under the dino's skin, but it's not working. They bring some food Buster likes to try to lure it out. After a couple of hours, there's no news. It's already night when you hear some rumbling in the distance. Everyone jolts awake. People around you are on high alert. You hide and wait. A large shadow the size of a school bus appears from the dark. A fully grown T-Rex can reach 40 feet long and 12 feet high. The giant lizard approaches the meat and sniffs it. After a couple of moments, it runs off. Everyone gets out of their hiding places and tries to follow the animal. The meat has a special substance in it. It was supposed to put the dino to sleep. This way, it wouldn't be a problem to bring it back to the lab. But the dino was smart enough to feel something suspicious. Despite its size, the T-Rex is quite slow. It can move at a speed of only 12 miles per hour and can't even outrun a human. But Buster somehow manages to cross a raging river and disappears into the dark forest. No one has been prepared to make it through such an obstacle, so the whole team makes a detour through the mountains. It's a difficult climb, with everyone carrying the equipment needed to catch the T-Rex. From the height of the mountain, you can see almost all the forest. Far away, treetops are shaking. The giant reptile is heading to the north. Everyone tries to get to the other side of the mountain as fast as they can. But then, one of the crew members slips and falls. Good thing a safety rope holds her in place. You pull the woman back to the path. You continue walking until you reach a cave. Everyone puts on their helmets with flashlights and goes inside. The deeper you go into the cave, the smaller it gets, so you have to crawl to get through. The rocks are sharp, and there's water everywhere. It's easy to get lost in here. The cave starts trembling. Everyone rushes to get through the narrowest part. You finally make it out of the cave. That's when you find out that the cave was trembling because of the T-Rex. It was stomping around the mountain. It spots your group and starts running towards you. People panic and rush back into the cave. The T-Rex catches up with your team and tries to snatch someone, but by that moment, everyone is already safely tucked inside the cave. Suddenly you scream, "Buster!" Shockingly, it seems to calm the creature down. You step outside, even though everyone is trying to hold you back. You get outside and face the massive creature. It's just staring at you. You slowly approach it, trying not to make any sudden moves. Someone from inside the cave gasps. It startles Buster. It starts thrashing and roaring, but you are still there, trying to calm the animal down. Eventually, it gets quieter and comes closer. You put your hand on its head, caressing it. After a few seconds, someone inside the cave steps on a twig and it cracks. The T-Rex jolts and runs away. You're furious. Now, you have to track it once again. After you spend many more hours in the forest, the sun starts to rise. Everyone is exhausted and about to pass out. You decide to call it a day and head back home. But as soon as your team gathers near the jeeps, you receive a notification that a giant T-Rex has entered the city. A helicopter picks up you and the other team members. There isn't enough room for everyone, so several people stay behind, waiting for the next chopper. The T-Rex is dashing through traffic. People in the streets are running for their lives. Dozens of news companies are filming the incident. Many people are posting it on social media. The dino breaks into the mall and destroys everything it sees. Your helicopter lands, and you get out, trying to think of a way to calm the creature down. You rush into the mall, but the T-Rex has already run away to the other side of the building and managed to escape. You're following it, but suddenly you get a phone call saying that the team members left behind in the forest have spotted your T-Rex. You can even see the live footage of the animal. That means there are 2 giant reptiles on the loose in your state.
Big herds of dinosaurs run through the forest. The temperature rises rapidly, and everything behind them begins to ignite. Some dinosaurs get stuck in swamps and can't get out. Pterodactyls fly over their heads as they try to avoid the blast wave that will soon cover the Earth. This event happened about 66 million years ago. It wiped out almost every living thing on Earth. Birds and flying dinosaurs were just about the only ones who could survive the most massive extinction event ever. Hey, don't blame me, I wasn't around then. Let's go down their evolutionary tree to look at the world's first bird, Archaeopteryx. It was about the size of a modern raven, but it looked like a small dinosaur with feathers. It had many small conical teeth, almost like alligators. It's because Archaeopteryx was closer to reptiles than to birds. However, its brain was 3 times larger than that of these reptiles. Although it had wings with feathers, it could hardly fly like modern birds. Its shoulder joints didn't allow it to lift its wings above its back, so it couldn't make a full wing beat. Most likely, Archaeopteryx was capable of gliding flights with small wing flaps. Evolution has led to more evolved species capable of full flight. Pterodactyls. These guys had no feathers, but membranes made of skin and muscle. Its wingspan was about the length of a human leg. It could fly perfectly and catch fish and small animals. Although flying dinosaurs could easily outrun terrestrial predators like velociraptors and T-Rexes, most of them didn't make it through the impact of a giant meteorite. Let's look at this event step by step to see how they got to our time. 10 minutes before the meteorite crash. A massive rock about the size of Manhattan Island is moving towards Earth in space. It weighs 460 trillion tons. That's like 3 trillion blue whales, the heaviest mammals that ever lived on Earth, and it's approaching our planet at 12 miles per second. At that speed, it could cross the Atlantic Ocean in just 4.5 minutes. That's twice as fast as our modern spacecraft could fly. 5 seconds before the meteorite crash. Ooh, this is getting tense. The Earth's gravitational force continues to pull the giant meteorite. It blows a hole in our atmosphere and creates a popping sound so loud you could hear it on the other side of our planet. All the animals on our planet wake up in a panic. They lift their heads up and see a huge rock that begins to burn through the air. Smaller fragments start to break away from the main meteorite. This fire is so bright that it shines almost like the sun. Flying dinosaurs and other ancestors of modern birds are the first to sense danger. They make a beeline to the sky and try to fly as far away from the impact site as possible to save their lives. The moment of impact. The colossal mass and velocity of the meteorite give it an enormous amount of energy. As soon as it touches the Earth, it causes an explosion of 150 trillion tons of TNT. The blast wave literally rips out chunks of our planet and throws them up. A huge wall of energy begins to move from the point of impact in all directions. It snatches the trees out with their roots and pushes them to the ground like dominoes. The shockwave completely wraps around our planet. This energy turns into heat. Everything around the impact site begins to ignite. Green jungles and trees turn into smoldering charcoal in seconds. The ground and rocks simply evaporate. The collision caused a massive earthquake. Some dinosaurs may have fallen into cracks that appeared in the ground. A strong earthquake caused a tsunami, with waves higher than the Empire State Building. Dinosaurs that weren't trapped in the burning forest were washed away by the enormous waves. The dinosaurs of North America tried to escape by running to the north, but the blast wave inevitably catches up with them. Flying dinosaurs have no problem with earthquakes or tsunamis. They fly high enough to avoid the giant waves, but they will have to contend with continuously falling meteorite debris. 5 minutes after the meteorite crash. A meteor shower of giant rock fragments continues to fall to Earth. Some meteorites were the size of a car, others were more like a large building. Ashes and dust rise into the air. Their temperature is so high that they melt and turn into liquid lava and then fall back to Earth, causing more fires. Meteor showers cause trouble for flying dinosaurs too. They have to maneuver and dodge the falling red-hot rocks. The high temperatures are a huge problem for them because it might make them lose feathers. With no feathers, they aren't able to fly. 10 hours after the meteorite crash. The dinosaurs continuously ran north all this time. They found themselves in unfamiliar territory with many swamps. Giant dinosaurs like T-Rexes have legs as long as an adult human's height. They have a chance to get through this terrain, But if they fell, they could never get back up. The smaller dinosaurs, like Triceratops, had short legs and couldn't go through the dense swamps. 1 month after the meteorite crash, 15 trillion tons of ash were ejected into our atmosphere. A dark cloud blocked the sun, and the Earth was immersed in complete darkness. Surviving plants couldn't feed on the sun's energy and stopped producing oxygen. Surviving dinosaurs could hardly breathe because of the lack of air and a large amount of dust. The lack of sunshine in the sky made phytoplankton disappear. Many marine animals were left without their only source of food. The dust and ashes in the atmosphere prevent our planet from getting heat from the sun, and the temperature here is beginning to drop. The place where the meteorite fell was rich in sulfur. This toxic acid evaporated at the time of the impact and formed in clouds. Now there are acid rains on Earth. Flying dinosaurs now have to hide from these rains. They have to stay in caves and can't go outside to get some food. So far, a large number of terrestrial and flying dinosaurs have survived. They come out to see the aftermath of the disaster. The site of the impact was in present-day Mexico, the Yucatan Peninsula. The Chicxulub crater is located here. It's about 93 miles wide, like half of all of Lake Michigan, and it's 12 miles deep. You could plunge the whole Mount Everest in there, and there would still be 6.5 miles of available space. It wasn't the impact itself that made the dinosaurs disappear. The fire destroyed most of the plants the herbivorous dinosaurs ate. With no food, their numbers dwindled rapidly. Predatory dinosaurs had nothing to eat either. Acid rain and the disappearance of phytoplankton threatened all marine life. Even though birds managed to avoid the blast waves and tsunami, they were short of food too. About 80% of all birds didn't make it to the end of the extinction event. The problem was that all of the forests on Earth were wiped out. Most birds would nest and live in trees. Besides that, the forests were always full of food, from all kinds of ants and termites to flying insects and small mice. So, only those species that lived on the ground and could fly well survived. Most likely, they fed on the seeds of small surviving plants. This habit made flying dinosaurs lose their teeth during evolution. Instead of jaws with a bunch of sharp teeth, they got long beaks to grab tiny seeds from the ground. Although Earth looks like a terrible place to live now, there's an evolutionary boom for birds. They have to travel long distances in search of food. Their wings get stronger. They also feel safe from predators who regarded them as food before. No T-Rex now catches a sleeping bird off guard. About 1,000 years after the collision, the first dense forests appear. It gives another boost to evolution. 1 million years later, forests full of food are populated by the ancestors of modern mouse birds. And 65 million years later, in modern times, we have about 10,000 species of birds. Pigeons, crows, eagles, and hawks, even penguins. These are all descendants of the dinosaurs. But there were other survivors. Some alligator and crocodile ancestors were able to adapt to changing conditions. About 80% of turtle species managed to survive the mass extinction, and now their descendants live among us. Snakes and lizards were also able to wait out the hard times in their burrows. Even some mammals, like monotremes, survived. This hedgehog-sized animal was able to continue to evolve. Many millions of years later, these mammals evolved into primates, which later gave life to modern humans. Much, much later came the iPhone. Hey, it's possible that Jurassic World is not just a fantasy. Dinosaurs could really be walking, swimming, or flying around somewhere out there, but not on Earth. Some scientists think there may be planets far, far away from our solar system where slightly different versions of T-Rex and other dinosaurs live. They got the idea based on the fact that our planet used to have about 30% higher oxygen levels than today. That's why complex and intelligent life forms like dinosaurs could develop in the first place. They also want to explore basic building blocks that are the reason why we have life on Earth. These building blocks are something we know as amino acids. They make proteins, sugars, and genetic material, RNA and DNA. They're consistent and mainly exist in one shape or orientation. There are two ways they can be oriented, right and left. That means they mirror each other, just like our hands. It's something we call chirality. For life to exist, proteins must have one form, which means they can be oriented right or left. On our home planet, almost all living things, from the smallest bugs to whales and elephants, have amino acids with a left-handed orientation. We're not exactly sure why things are set that way, but there's a theory that's because of meteorites that crash-landed on Earth 4 billion years ago. They brought specific kinds of amino acids and some other organic materials to our planet and somehow set the pattern we have today. Maybe we could use special telescopes we created to search planets, especially those where conditions are similar to how they used to be on Earth back in time when dinosaurs existed. In that case, it would be better to watch them from a safe distance, because, considering what they might look like, researchers say it might be a safer choice. That's a cool idea, but it's still very tricky. The history of life on our planet, especially that of dinosaurs, involved many catastrophic events and mass extinctions. There's always more room for new theories about dinosaurs. One of them says oil comes from dinosaurs. Interesting, but not true. Oil formed from the remains of sea animals and plants from millions of years ago. This was way before dinosaurs appeared. Tiny organisms ended up at the bottom of the sea. As bacteria decomposed animals and plants, they removed most of the oxygen and some other elements from them. It left behind only a sludge, which was mostly made of hydrogen and carbon. As time passed, those remains became covered with many layers of silt and sand. When the depth of the sediment increased to 10,000 feet or even more, heat and pressure turned the remains into natural gas and crude oil. It's possible that dinosaurs lived or fell in the sea and later became petroleum in the same manner. But no one has ever found crude oil containing their skeletons. So this is just an unproven theory. Then there's the feathered dinosaur theory, which, unlike the previous one, seems to have more foothold in reality. Back in 2010, researchers found evidence that 100 million years ago, there had been a dino species with ginger feathers. Another group of scientists claimed there had been a different species from 150 million years ago. Those dinos had freckles and reddish-brown feathers on the tops of their heads. The color patterns probably had their purpose. Maybe it was a way to communicate with other representatives of their species or to attract mates. But years later, scientists studied the Microraptor, also called a feathered dinosaur. They realized it had probably been more like a bird than a dinosaur. The key point is how birds replace their feathers. Birds that fly have to replace their feathers in a specific order, otherwise they won't be able to fly very well. And the Microraptor's fossils showed that this creature had changed its feathers in a similar pattern. So they're not really sure which category this animal falls into. Dinosaurs that had feathers shed a lot of their skin piece by piece, like dandruff. Hey Bob, looking a little flaky there. Need a new shampoo? Yeah, they didn't shed their skins like lizards do, as if they take off an old suit. When we talk about dinosaurs, we usually don't picture them as social creatures, more like isolated ones similar to lizards. But some researchers discovered an 80-million-year-old collection of clutches in the Gobi Desert. It means there were colonies of dinosaurs that protected their nests and guarded their young, similar to birds. Crocodiles are known for doing that too. Pterosaurs were flying dinosaurs, and pelycosaurs were fin-backed ones. Some studies have shown that these two species used their exaggerated head crests and sails or fins to get to their potential partners. There are many theories about their crests and what they were needed for, though. Some experts believe that was how dinosaurs regulated their temperature. Others think they needed a crest to steer through the air. It's hard to say anything for sure since their fossils are rare and they don't have living descendants. But the most likely option is that the crest had the same purpose as a peacock's tail and was used for selecting mates. The bigger the crest, the more chances a pterosaur had to get a partner. You know theropods, those scary meat-eating predators that are shown in most dinosaur movies? Well, they might have enjoyed eating plants way more than tearing flesh. Not all of them, but it's possible that many of them weren't as fierce as we might think. Those big scary ones, like T-Rex, could be exceptions rather than the rule. The thing is, movies show these creatures to be way faster than they probably were in reality. They could probably run just a little bit more quickly than the average human runner. Scientists study the diet of coelurosaurs. Those seem to be the closest relative to birds. It was hard to figure it out because some of the dinos from this group had peg-like teeth, or in some cases, no teeth at all. To understand what they ate, researchers had to look for direct evidence and check if there was anything in their stomachs. And after they discovered certain things, including a beak with no teeth, they realized these fellas had followed a vegetarian diet most of the time. Even some famous ones, such as velociraptors, could be just innocent plant eaters and not terrifying beasts from Jurassic Park and our childhood nightmares. Over 10 years ago, scientists found fossils of a small dinosaur. It was a creature as big as a parrot with long legs. It came from a family with some of the most famous predators we know about, such as T-Rex and Velociraptor. Most dinosaurs that lived on land had 5 fingers, but later some of them ended up with fewer fingers. This new one they discovered was special because instead of having 3 fingers, which was more common for its family, it had just 1 finger with a sharp curved nail at the end of each front limb. This creature probably used this 1 finger to dig into insects' nests to feast. Even though we know all about the asteroid that wiped out dinosaurs, some have other theories. One paleontologist even had an idea that dinosaurs had possibly reached their end because they had been eating one another. This especially worked for ancestors of fierce, scary predators such as the Tyrannosaurus rex. It's possible they ate so many eggs of other dinosaurs that many species just went extinct. Once they started eating the eggs of very big dinos that we know as sauropods, it's possible they started getting bigger too. And no dinosaur mother could stop them from eating her eggs because she couldn't be around all the time. There were other big predatory animals that ate eggs, even early mammals. But in any case, later research showed dinosaurs couldn't have eaten enough eggs to have caused mass extinction. And that's all I have to say about that. So, theoretically, humans can survive an asteroid that has the potential to destroy entire planets. It won't be a walk in the park, though. Let's go back in time to 66 million years ago, in the late Cretaceous period. The Earth, before humans, where dinosaurs are thriving. The plants and animals are rich and diverse. You'd see a T-Rex chasing a Triceratops, or the massive Alamosaurus, one of the biggest animals to ever roam the planet, towering over the landscape. In Texas, they remember the Alamosaurus. And watch out for the Ankylosaurus, a living tank swinging its tail like a wrecking ball at any threat. As you're about to enjoy a quiet evening under the stars, a bright new light appears in the sky of the northern hemisphere. Now, a new star in the sky doesn't really stand out at first. It's just twinkling like the rest. But give it a few hours and you'll notice it's getting brighter. Check again the next night and boom, it's the brightest thing in the sky, outshining planets and even the moon. Then finally, it horrifyingly outshines the sun. The star was the Chicxulub asteroid, which left a gigantic crater now called Chicxulub crater in Mexico's Yucatan Peninsula. The asteroid enters the Earth's atmosphere at a blistering 12.5 miles per second. It blasts through 60 miles of the atmosphere in about 3 seconds. It falls so fast that even the air can't get out of its way. The air gets squashed and heats up to thousands of degrees in a blink. Before the asteroid even touches the ground, this super hot air has already vaporized much of the sea where it's about to strike, near the Yucatan Peninsula. Then, in a flash, the asteroid smashes into the Earth, screaming over Central America with a loud boom that echoes everywhere. It doesn't just smash the ground, it makes the soil and rock flow like liquid. The asteroid digs a hole so wide and deep that it nearly touches Earth's inner layers and throws up dirt more than 20 miles high. At that exact moment of impact, the asteroid also turns its massive speed and weight into heat in a split second. It puts so much energy into the Earth that it makes molecules move faster than the surface of the Sun. This massive energy created a giant ball of plasma, superhot charged gas that includes bits of vaporized rock. This all shot out at incredible speeds. The shockwave from the impact and the heat turned the Earth around the crash site into gas instantly. This set off earthquakes all around the world. And it's not just the rocks flying around that you need to worry about. As they plummet through the sky, they rub against the air, heating up so much that they set fires all around the world. The heat they give off could be compared to an oven cranked up to its highest setting. This fiery shower causes most of the world's trees to burn down. The entire world is now on fire. Soon it changes everything. In a blink, dinosaurs were wiped out, making way for mammals to rise. And not only dinosaurs, 75% of species and big creatures disappeared, leaving behind only some small birds and critters. So, how could you, a human, survive something like that? Now, some animals made it back then. To survive, we need to learn from their resilience. The only birds that survive even in the toughest conditions are the ones nesting safely on the ground. Among the few larger animals that manage to dodge extinction, all have ways to deal with the heat. Some, like certain small mammals, snakes, and lizards, can dig themselves into cooler underground burrows. Others, like crocodiles and turtles, just hide in the water. So, if you're exactly on the other side of the planet when the strike happens, and you act super fast, you might just make it. Right now, the impact is about 10,000 miles away, but don't underestimate its power. As soon as you hear the loud boom, head underground as quickly as you can. And be careful, because you'll feel the earth shake about 30 minutes later. Hide in a deep cave, preferably with a narrow entrance. It would protect you from the falling debris, and the temperatures underground would be stable. Also, some caves have natural water sources, rivers or streams. You might also prepare for the not-so-great diet of insects, fungi, or poor small animals that also seek refuge in the cave system. But it's better than nothing. You also need to be extremely far away from any large bodies of water. Being near the ocean might seem like a safe bet during a massive asteroid impact because the sea can buffer extreme temperature changes. But the earthquakes trigger terrifying tsunamis, even in lakes or fjords. The asteroid's crash sets off not just one tsunami, but many, and they're as tall as skyscrapers. Within an hour, colossal waves between 600 and 1,000 feet high hit the Gulf Coast, slamming into places like Mexico and the southern United States, and flooding miles inland. These waves are so powerful, they even push rivers backward. These tsunamis continue around coastlines, reaching the east coast of the United States, and 6 hours later, they hit Europe, Africa, and the Mediterranean. By 15 hours after the impact, there isn't a coastline on Earth that hasn't felt the wrath of these waves. Well, let's say you survived the initial impact somewhere deep underground, but your troubles have only begun. The Chicxulub asteroid strikes a region loaded with sulfur. This sends 100 billion tons of sulfur and an enormous amount of water into the sky. The water vapor forms massive storm clouds. They start to rain acid. In colder places, huge snowstorms bury the land under feet of snow each day. The impact also vaporizes massive amounts of oil, throwing up 150 football stadiums worth of it into the air. This oil turns into a thick black soot in the stratosphere. It coats the Earth like black paint. And even when the acid rain calms down, this carbon stays up above the clouds and doesn't wash away. This sooty layer blocks out 90% of sunlight, plunging the Earth into a cold darkness that lasts for at least 3 years. The world cools down by about 50 degrees on average. Now, when you finally leave your deep cave, you must look for places where you won't freeze. The only spots spared from the frost are tropical islands like Madagascar, India, which was an island back then, and Indonesia. These places have surviving plants and animals, and they even continue to get fresh water, unlike most of the world. Everything else in the world looks like a huge nuclear wasteland. These tropical islands are safe spots during an asteroid apocalypse, but don't think of them as paradise. These places still only get about 10% of their usual sunlight and barely enough rain to avoid turning into deserts. In this chilly, gloomy setting, most food chains fall apart. If you want to survive, you'll need to bring lots of extra food with you, for the next 6 years at least. Now, some things are lucky enough to survive. Fossils tell us that freshwater ecosystems did well, so staying close to a river or estuary might be your best shot at finding food. You could come across turtles, crocodiles, and some fish. Animals like clams, snails, and small crustaceans that live in the sediment also manage to hang on. And while a bit warmer than everything else, these places are no walk in the park. You'd need to pack warm clothes to have any chance of survival. Now, if we add all this together, the best spot for surviving the Chicxulub asteroid would be Indonesia. It's a mountainous, tropical country that consists of several islands. There, you'll find bearable temperatures, a bit of rainwater, and a deep cave for shelter. This could protect you from the falling tektites, the intense heat, and even help you find something to eat in the rivers and lakes. But if you stumble upon any shrew-like creatures while scavenging for food, time traveler, please let them be. It's not clear how many survived the Chicxulub impact, and eating one could have unforeseen effects on the future of humanity. Like, don't eat your great-great-great-great-great-great-grandfather, right?
Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer, though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And, most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1P/Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the Sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the Sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's Comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Sheqi and Wenxian Thungkao chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar. around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910, one day after Halley's had emerged from behind the far side of the sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's Comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets, in general, may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids, though. Unlike asteroids, which are small rocky space bodies also orbiting the sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's Comet appears to have formed in the Oort cloud at the outer edges of the solar system, but Borrelly is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs.
If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX, and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare. Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid. All because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system.
Look at this star. It lies at the heart of its system and makes up 99.8% of its mass. It's a relatively young star and part of a generation of stars known as Population 1. Yep, there's an older star generation called Population 2, and an even older, and not even proven, Population 3. Anyway, this star was born around 4.6 billion years ago. It most likely formed from a giant, rotating cloud of dust and gas. Such clouds of space matter are called nebulas. One day, the nebula started spinning faster and faster because of the force of its own gravity, and then it flattened into a disk, and most of the material got pulled towards the center, forming a star. But it's all in the past. Right now, you see a ginormous comet flying towards the star. Are they going to collide? Well, it's time to reveal all secrets. The star I'm talking about is our Sun, and the comet approaching it at a breakneck speed is 96P Mach-Holtz 1. The comet is around 3.7 miles wide. Astronomers think it might have arrived from outside the solar system. The NASA ESA Solar and Heliospheric Observatory spacecraft is monitoring the comet as it's dashing towards our star. Right now, it's moving inside Mercury's orbit, leaving an icy trail as it's nearing the Sun. Now, look at this. That's the comet's trail. It's mostly made up of gas. It's trickling behind the frozen chunks of ice that are getting heated by the radiation coming from the Sun. In some cases, a comet can have two tails, one made of dust and the other consisting of gas. And each of them can reach hundreds and, in some extreme situations, even millions of miles in length. In 2008, scientists analyzed the material left by 150 comets. They found out that the comet we're talking about was quite low in carbon and didn't contain a large enough amount of some other typical materials. This could only mean one thing. The comet was an interloper coming from another star system. It may have been ejected from its original solar system by the gravity of a large planet. After that, the poor homeless celestial body probably spent a large amount of time wandering space, until it came across Jupiter. The gas giant could have bent the comet's trajectory, trapping it in orbit around the Sun. There's one more theory. According to it, the comet formed in a poorly studied region of the solar system, and it has this weird composition due to its repeated journeys around the Sun. Now, scientists are watching the comet with bated breath. They're sure that once it collides with the Sun, they'll be able to learn new information about this space wanderer. And since the comet is an atypical one, both in its behavior and composition, they don't know what they will see, which makes the whole process even more exciting. David Machholz, yes, that's the one who the comet was named after, first noticed this space body in 1986 with the help of a homemade cardboard telescope. The most surprising thing about this discovery is that most comets falling towards the Sun are quite small, not more than 32 feet across. That's why they burn up as soon as they come close to the Sun. But the sheer size of Machholz 1, which is more than 2/3 the height of Mount Everest, seems to protect the comet from evaporating completely. The SOHO has already recorded the comet making 5 close passes around the Sun. The most recent one happened on January 31st, 2023. The giant comet was 3 times closer to the Sun than Mercury. But what would happen if a space body like this one crashed into our star? There is a special name for comets that come too close to the Sun: sun grazers. They can pass a few thousand miles away from the star's surface. At the same time, we know that the Sun doesn't have a surface. It's a giant ball of immensely hot gases, mostly hydrogen. Comets that get too close to the star can pass through its Roche limit. After this border, space travelers usually get ripped apart by incredibly strong gravitational forces, or at least that's what happens to small or structurally weak comets. But our comet is neither weak nor small. It can potentially survive the Sun's gravity and cross the Roche limit again, leaving the dangerous zone. But such comets have other problems, because solar radiation and heat are powerful enough to crack rocks. So imagine 96P Machholz 1 speeding towards the Sun. It's moving faster and faster, crossing the Roche limit, and it looks as if it's not gonna stop. Soon, it's dashing at a speed of 370 miles per second. And then, boom! The comet gets flattened by the Sun's atmosphere. This generates a truly spectacular explosion. It throws out countless tidal waves of X-rays and ultraviolet radiation. This explosion unleashes as much energy as a coronal mass ejection or a powerful magnetic flare. The momentum makes the Sun ring like a bell. Then, a series of sunquakes echo through the solar atmosphere, and that's what might happen if a massive comet crashes into our star. Scientists admit that their theories are just speculations. For one thing, a Sun-hitting comet hasn't been seen yet. Plus, no one is sure what physics will determine its fate. Astronomers know about comets that came pretty close to the Sun and survived this feat. For example, in 2011, it was a comet named Lovejoy. It passed through the corona, the outermost part of the Sun's atmosphere, usually hidden by the blindingly bright light of the surface of our star. When the comet emerged, it was much worse to wear, that's true, but it was still intact. Another comet that survived this dangerous approach, though barely, was Ison, and it happened in 2014. So, what does a comet need to reach the Sun's lower atmosphere? A mass of more than 1 million tons. This lower limit is about 100 times smaller than comets Lovejoy and Ison. There are long-period comets that take more than 200 years to orbit the Sun. scientists think they might originate in the Oort cloud. It's the most distant region of the solar system, its outskirts, so to speak. It's a collection of icy objects farther away from us than anything else in the solar system. It lies at a distance between 2,000 and 100,000 astronomical units away from the Sun, and 1 AU is around 93 million miles. This region is also described as a cometary reservoir. No wonder, according to some estimates, there are more than 1 trillion icy objects there. So, some of them are bound to wander off, right? You can also find an estimated trillion or even more comets in the Kuiper Belt. This region lies beyond the orbit of Neptune. It's a donut-shaped ring of icy objects surrounding the Sun, 30 to 55 AU from our star. Short-period comets that take less than 200 years to orbit the Sun appear there. The first mission to explore this distant region was New Horizons. Right now, it remains deep in the Kuiper Belt, speeding away from Earth at a rate of about 300 million miles per year. There are also dwarf planets dwelling inside the Kuiper Belt. Some of them have their own moons, and this egg-shaped planet, Haumea, even has a ring of its own. By the way, a dwarf planet's atmosphere can collapse if its orbit takes it far away from the Sun. A bonus fact, even though you might not have noticed it, we live inside the Sun. No, I didn't mean that we literally inhabit the star that is 93 million miles away. The thing is, the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, exactly the gust of solar winds creates such a breathtaking phenomenon as the northern and southern lights. Imagine wildfires raging across the continent, tsunamis crashing against coastlines, and almost 75% of species on our planet going extinct. That's what happened when the most devastating asteroid we know about hit our planet. Yes, I'm talking about the one that wiped dinos off the face of the Earth. But I've got some shocking news in store. This asteroid might have had a companion. Scientists discovered something that might be an impact crater 250 miles off the coast of West Africa. They were looking at the data from the seismic waves that the researchers had sent underground. Their goal was to check the ocean floor's terrain by observing the waves ripple through Earth. Than the eruption and tsunami in Tonga in January 2022. The hit would have also produced shockwaves equivalent to a magnitude 6.5 to 7 earthquake. It would have triggered underwater landslides, as well as a series of tsunamis. In any case, discoveries of such terrestrial impact craters are always a big deal. They're quite rare. Researchers have found fewer than 200 confirmed impact craters on Earth. Almost all of them have been discovered on land. There are also several likely candidates, but their origin hasn't been confirmed yet. What can the newly found crater be if it wasn't left by an asteroid? It could be a collapsed volcanic caldera, or it could be a salt diapir, which is a squeezed body of salt. To confirm that the Nadir crater was created by an asteroid strike, scientists need to drill into the formation and gather samples. The evidence scientists are looking for might be shocked quartz, a mineral that appears when asteroids crash into our planet. If we do find it, we'll hopefully learn whether this discovery has any connection to the Chicxulub. Its fall led to terrifying consequences on Earth. The asteroid is believed to have come from the outer reaches of the solar system. When it crashed into the planet, the force of the collision was so powerful that the space rock didn't stop until it got through Earth's crust to a depth of several miles. The impact left a crater more than 100 miles across. Thousands of cubic miles of solid rock instantly turned into vapor. The crash set off a series of natural disasters that erased around 75% of plant and animal species on Earth. Animals that were close enough to see the crash didn't survive for longer than a few seconds. Close to the impact crater, the ground was covered with thousands of feet of hot ash, grit, and rubble. Several seconds after the collision, everything for many miles around burst into flames. what didn't burn down within the next several minutes faced a different, even more terrifying problem. The asteroid also produced a monstrous, largest ever tsunami. A recent study claims that it was thousands of times larger than any wave people have ever seen. You see, the splashdown was so powerful that it left its signature on the face of our planet. In 2021, researchers found out that the collision had carved mega ripples into the Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists even remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. And of course, all that empty place didn't stay empty for long. The ocean gushed back to fill the crater, but in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall and moved at a speed 10 times greater than more distant tsunami waves. During the first hours after the crash, the sky was almost totally dark. Later, it started to get lighter, but very, very slowly. For the next couple of years, the world seemed to be stuck between a cloudy day and twilight. Lots of plants didn't survive this dimness and the absence of sunlight. The ash stayed in the air for months. That's why when it rained, the water became highly acidic. Fires kept raging. They produced tons of toxic gases that destroyed the ozone layer, at least for some time. The gases and particles that had been flung into the atmosphere blotted the sun out. This caused temperatures to plummet by over 60 degrees Fahrenheit. Lots of plant and animal species that managed to survive the impact itself couldn't stand these new hostile conditions. By the way, the infamous asteroid could have also been part of a shower, since there's some evidence that many other space rocks smashed into the moon at approximately the same time. In December 2020, some glass was found on the moon. It could have been forming there over billions of years as the soil was ejected during asteroid impacts. The discovered glass was delivered to Earth by the Chinese National Space Agency's Chang'e 5 lunar mission. Researchers have concluded that the super tiny glass beads were indeed created by the heat and pressure of meteorite impacts. It means that their age should be the same as the time of the collision. Using the glass beads, scientists managed to create the timeline of such collisions. They think the timings of asteroids hitting the moon could mirror the impacts of asteroids hitting our planet. Even more exciting, scientists have found out that the age of some lunar glass beads coincides with the age of some of the largest impact craters on Earth, including the Chicxulub impact crater. If this theory about smaller impacts accompanying large impact events on our planet turns out to be true, we'll get important information about asteroid impacts on Earth and the inner solar system. Now, researchers are planning to compare the data received from the Chang'e 5 samples with other samples of the lunar soil from different craters. It may reveal new evidence about what impacts may have influenced life on Earth.
Asteroids flying around is sometimes like a fierce game of dodgeball, where you never know when some of them can go in your direction. So we can just track the situation and hope for the best. To figure out the risks, scientists from different organizations have to study the positions and paths of the asteroids that come close to our planet, especially those that are at least 0.6 miles wide. And the good news is that none of these asteroids will probably hit us for at least the next 1,000 years. Phew! To give us an idea of their power, scientists did an experiment to simulate the impact of such a gigantic asteroid. The energy released from the collision would be a mind-blowing 100,000 megatons. That's like detonating 15,000 tons of dynamite. Also, if such a big asteroid hit us, Earth would cool down significantly because of all that debris that would go into the atmosphere and block sunlight. Plants wouldn't be able to get their fuel in this case, so we'd all be in trouble, both humans and animals. Thankfully, such mammoth asteroid impacts are quite rare. The larger an asteroid, the longer it takes it to collide with Earth. For example, it's estimated that asteroids with diameters of at least 0.6 miles strike our planet about once every 700,000 years. And if we're talking about even bigger ones that are 3 miles wide, well, those are predicted to come crashing down only once every 30 million years. Yay! But hold on. Don't get too relaxed just yet. Astronomers focus on really large asteroids because those are the ones that can kinda doom our planet if they hit us. Yep, you got it right. In a dinosaur kind of way. Even if one of them didn't erase us completely, the damage would still be enormous. So, there are still some asteroids wandering around that we need to keep an eye on to see how they might evolve over time. Scientists have a model of tracking them where they focus on the parts of an asteroid's path that come close to our planet to see if the space rock poses a risk to us. And it seems there might be one asteroid, 7482, 1994 PC1, 3,600 feet in diameter that might pose some danger. It's supposed to come closer to our planet in the next 1,000 years. And when I say risky, it means there's a 0.0151% chance of it coming within one Earth-Moon distance. It already passed by us in 2022, but we were lucky because it was far enough 1.2 million miles. I'd say we can relax when it comes to asteroid scenarios. For now. Asteroids slamming into Earth would be new for humankind, but not for the planet itself. As I said, there weren't many of those big ones, but they still had enormous consequences. The first one that comes to most people's minds is, of course, the dinosaur asteroid as big as a mountain that struck our home planet around 66 million years ago, near Mexico's Yucatan Peninsula. It was chaotic. Global firestorms and tsunamis were all over the place. Dust was blocking out the sun, and vaporized rock released sulfur, which then led to acid rain and the acidification of the oceans. But there was an even bigger fella that came before that one. Around 2 billion years ago, a gigantic asteroid crashed into our planet and left a massive crater in South Africa. The one we know today as the Redefort crater. And it seems this asteroid might have been even bigger than we all originally thought. Twice as wide as the space rock that erased dinosaurs. The Redefort crater is confirmed to be the biggest visible crater on Earth, with a diameter of about 99 miles. It used to be even bigger when it first formed, though. Maybe even 155 to 174 miles across. It's hard to figure out its true size because the crater has been eroding for the past 2 billion years. Think of it like slicing off layers from the rim of a bowl. The diameter gets smaller with each slice. When the asteroid, 7 or 5 miles wide, that wiped away dinosaurs hit Earth about 66 million years ago, it caused massive destruction. Forest fires, acid rain, tsunamis, and so much ash and dust that it changed Earth's climate. This all made about 75% of life on our planet extinct. The asteroid that created the Redefort crater was not only bigger, but it also traveled at a higher speed, which means the consequences there would have been even worse. But it happened a long time ago, and living beings were different back then. Maybe it was some bacteria that didn't even notice that something unusual was happening. Earth is not the only one. Lots of impacts have happened across our solar system too. For example, in our close neighborhood. Yup, moving to Mercury and its massive crater called the Caloris Basin. It measures about 950 miles across, which is more than the state of Texas. There's a ring of towering mountains around the crater which makes it look even more impressive. You can see different colors in the mosaic image of the Caloris Basin. They tell us more about the geology of the basin. The orange parts represent lava that once flooded the basin. These lava flows covered the original surface and added this specific orange hue. And after the lava flooded the basin on Mercury, smaller craters formed on top of the lava surface. These craters dug into the ground and uncovered the material hidden beneath the lava. Some of this material is blue in color. And this blue stuff could be a clue about what the original floor of the basin had looked like before the lava covered it. Venus, the hottest planet in our solar system, has a thick atmosphere that comes with a pretty good defense system against space rocks. It's so dense that it burns up most meteors before they even reach its surface. As a result, you won't see as many visible craters on Venus as on other rocky planets in our solar system. But Venus still has some scars that can tell us about some serious impacts that happened there. And one of the biggest scars we know about is Meade Crater. It's enormous, about 170 miles in diameter. The inner floor of this crater is relatively flat and kind of brighter than its surroundings. It's possible that the crater ended up filled with a mixture of melted rock after the impact, and maybe even lava from volcanic activity on Venus. Want to get an idea of what Earth might look like without its protective layer called atmosphere? Just take a look at the Moon. Its surface is littered with impact craters. This Tycho is one of the craters you'll easily notice on the Moon. When you look at the full moon, you can spot it as a distinct circle with bright rays that radiate outward, slightly off-center on the lower left side of the Moon. This crater, 53 miles wide, has a beautiful central peak in the middle that's topped with an intriguing boulder. The size of this boulder is impressive. It would fill about half of a typical city block here on Earth. When talking about craters, we definitely can't leave out Mars. The red planet has a much thinner atmosphere than Earth. When spacecraft approach Mars, they rely on the planet's atmosphere to slow them down as they enter it. And indeed, the atmosphere helps slow spacecraft down during landing, but it's still not thick enough to completely protect Mars from all those space rocks that are coming all the time. From July to September 2018, a dark spot appeared on the southern pole of Mars. It consists of two distinct patterns. A theory says that the bigger, lighter-colored blast pattern can be the result of an impact shock wave scouring the ice surface. The impact generated winds that spread out and scoured the ice. The inner blast pattern, which is darker in color, occurred because the impacting object managed to penetrate the thin ice layer. As it hit the surface, it sent dark sand and debris flying in all directions.
Whoosh! Debris runs through outer space all the time, often heading towards our planet. We're mostly not aware of it. Most of that debris burns up when it enters our atmosphere anyway. We do get to enjoy the bright blaze in the clear night sky because, from time to time, we see it as fleeting meteor showers. But sometimes, a meteorite is tough enough to survive the atmosphere and large enough to leave a remarkable spot on our planet. We're talking about what often looks like nearly circular excavated holes. Nestled in the Colorado Plateau in northern Arizona, Barringer Crater is a rimmed pit in the shape of a bowl we also call Meteor Crater. It's relatively young since it formed only 50,000 years ago. There was this enormous iron meteor that hit at eye-watering speeds of up to 26,000 miles per hour. It exploded so hard that the meteorite excavated an amazing 175 million tons of rock. Daniel M. Barringer first identified this crater. He strongly believed the pit was a result of a meteor hitting our planet, but not many scientists believed him. Barringer spent a couple of years investigating this crater to prove his theory. Not just that, he also hoped to find some of the valuable metal content, but a major part of this once pretty large meteorite would have been destroyed during the collision. Kali Crater. At first, it seems like you're looking at a nice swimming pool, but 7,500 years ago, another meteorite headed towards the Earth. While passing by through our planet's atmosphere, it fell apart and hit our planet in fragments. That's how Kali Meteorite Crater Field formed. A group of 9 meteorite craters in the Estonian village of Kali. That's located on one of the country's islands. The largest crater ended up being 360 feet wide and 72 feet deep. The rest of the 8 smaller holes are located right around the main one. It's a tourist attraction today, but imagine how panicked our prehistoric ancestors that lived there must have felt while watching these gigantic rocks fall from the sky. Also, there's a chance the surface of this island was covered in forest, but it all probably burned down during the impact. South Africa has its own gem too, Fort Crater, the largest and the oldest one in the world. More than 2 billion years ago, a meteorite with a diameter of 6 miles struck our planet close to today's Johannesburg, South Africa. This impact was nearly twice as powerful as the one that made the dinosaurs go extinct. Almost right after the meteorite hit the ground, the crater formed. The hole shallowed and widened as the rock below began to rebound, plus its walls collapsed. The meteorite that hit this spot was probably 6 to 9 miles in diameter. If a celestial object that hit the Earth is bigger than 0.6 miles, it could have effects on the global level. So this one probably caused fires across the world. Also, enormous amounts of dust probably ended up in the atmosphere, which changed the climate for months, maybe even years. Lonar Crater is an astonishing spot in southern India, discovered almost 200 years ago. The pit lies within a large plain of basaltic rock left over from violent volcanic eruptions in this area, which happened 65 million years ago. Scientists even thought it was a volcanic crater at first, but soon they realized it was the result of a strong meteor impact up to 50,000 years ago. Look how specific basaltic rock is. And Lonar Crater is the only one formed in such a type of rock. There are trees all across the lower crater hills. And you can find a couple of interesting species over there, such as chinkra, peafowl, and gazelles. Plus, you can see many migratory birds flocking to the lake in the cold winter months. Yup, there's a lake there, and it's both alkaline and saline. In 2020, it surprised the local people because it changed its color to a rosy pink. It seemed unusual at first, but then scientists discovered such a specific color was the result of a growing population of a specific type of salt-loving microscopic organisms that produce such a pink pigment. This place is important for Indian mythology too, which is why there are multiple temples around the edge of the crater. Here's something really remarkable. The Rias crater contains an entire town within its inner ring. It's a small town in Germany. You can see the full result of this impact only from the air. The town walls highlight the inner ring of this crater that's about 0.6 miles, 1 kilometer, in diameter. Those are probably the dimensions of the meteorite that formed the crater. You can't distinguish the rest of it so easily since the crater has been eroded away. That means natural forces such as rain and winds have changed it. In the heart of the Ungava Plateau lies the amazing Chicxulub crater. The crater has its own pristine rainwater, some of the purest water you could find. It's not in any way linked to other lakes in that area, nor does it receive water from them. The water there accumulates from snow and rain. It's only lost when it evaporates. The depth of almost 900 feet is like a window to the crater's rich geological past. Scientists found different elements such as cobalt, nickel, and iron that helped them determine it was a specific type of meteorite where its parent body hadn't modified it in any way. The parent body is the celestial body from which a single meteorite or an entire class of them originate. Chicxulub crater formed over 1 million years ago. There are even traces of stone set in a circular arrangement and rock shelters. People that used to live in this area would set up camps on the ridges of the crater. It was a good position for them to catch animals and stay safe at the same time. Australia is home to some of the world's most fascinating impact craters. In its western part, you can find the massive Wolf Creek crater. It's the world's second largest crater that lies on the edge of the Great Sandy Desert. More than 100,000 years ago, one meteor was most likely traveling at crazy speeds of 10 miles per second before finally slamming into the desert. Scientists discovered it in the middle of the 20th century, but local people had known about it long before that. They had many cultural stories about that crater. One was about two ancestral snakes who were so incredibly big they managed to form both Wolf and the nearby Sturt Creeks as they were making their way across the desert. One of those giants emerged from the ground, and that's where the big crater is today. It's dangerous to climb there since rocks are pretty loose, but that's where you can see some interesting animals like brown ring-tailed dragon lizards catching insects for lunch, or Major Mitchell's cockatoo harvesting seeds from the plants that grow on the crater floor. Another must-see crater in Australia is Goss's Bluff. It lies in the heart of the continent, sandwiched between the James Range and the McDonnell Range. It's a place of great cultural importance, so if you're visiting, respect signs stating which areas you're not allowed to access. A giant meteor slammed into our planet more than 140 million years ago. It was a really long time ago, so the original crater has been eroded through time. But even today, you can still see its core. A central ring of hills nearly 3 miles in diameter. This looks like you're on Mars, doesn't it? It's actually southwestern Algeria, and its famous Amguid crater. This one is relatively young, considering it's a result of a meteor impact that happened 100,000 years ago. This crater has an almost perfectly circular shape. Its center is unusually flat because of the type of soil at the bottom and the fact it's tightly compacted.
Researchers have been waiting for this find for a long time. They came in all shapes and sizes. It would have been hard to distinguish them from dinosaurs. Most species weren't bigger than a mouse. It's like a reminder of a long-gone era when its ancestors walked on all fours. The first mammals to walk the Earth were different from us humans in one important aspect. We walk on 2 legs. That makes us bipedal. But the first animals that made the transition from sea to land were tetrapods. This means they walked on 4 legs. The story of these creatures began in present-day Scotland. The region is home to the first terrestrial ecosystem in the world. The rock here is made from silica. This material is the building block of glass. Hot volcanic springs formed these rocks more than 400 million years ago. Such land composition is a treasure trove for paleontologists. These are the scientists who study the fossil remains of animals and plants. In Scotland, they found everything from plants with preserved cells to the oldest known fossils of insects. They even discovered a fungus that grew up to 29 feet tall. But there was one find that stood out from all the other ones. In 2015, scientists unearthed fossils of 4-legged animals. The place of discovery was Willie's Hole, near the hillside village of Churnside in the south of the country. Researchers dated the finds to the Paleozoic era, about 360 million years ago. This was the time when the early ancestors of the dinosaurs thrived. The world was a much different place back then. Today, we associate Scotland with cold and rain, and kilts and golf. But at that time, this land sat closer to the equator. It had lush vegetation, and its climate was hot and humid. Droughts and flooding were quite common. It was the perfect setting for an important evolutionary event. Researchers have been waiting for this find for a long time. The fossil records had a 15 million year gap. Its name was Romer's Gap, after the Harvard professor who described it. Science was missing fossil evidence of the animals that ventured onto land on all fours. The 5 fossil species they found in Scotland shed light on this mystery. The first tetrapods were divided into 2 large groups. One of them contained the ancestors of birds, reptiles, and mammals. Their collective name is Amniotus. The other included the ancestors of amphibians, such as frogs. When these and similar species migrated to dry land, they discovered that they weren't alone. The earliest life forms that made this evolutionary leap were liverwort-like plants. We know this because scientists found their spores. They also discovered fossilized remains of an air-breathing millipede. It had tiny holes that allowed it to breathe air. This puts it among the first oxygen-breathing animals on the planet. And this species of millipedes is the first land dweller in the animal kingdom. Today, the largest of such creatures is the African elephant. Scientists believe that one of the first 4-legged creatures to make it onto land was an amphibian ancestor. Its name was Ichthyostega. The first part of the animal's name translates from ancient Greek as fish. This reveals a lot about the way the creature moved. It dragged itself on the ground using only its front limbs that resembled fins. This is the way that mudskipper fish move on land today. This isn't how we imagine proper walking, but during the period our hero lived on Earth, it was the perfect way to get around. The climate had both extremely dry and wet periods. The ability to walk and swim at the same time was especially useful. The fossils from Scotland supported this claim. The fish-like animals scientists found had 4 slender limbs. This is the perfect equipment for life on land, not inside the ocean. There was further evidence. The fossils displayed well-developed lungs for breathing outside of water, but their legs were still too weak to completely lift the body off the ground. The tail section had to slither along the surface, similar to how a snake moves forward. This animal that resembled a modern-day salamander lived during the Paleozoic era. This was the time when 4-legged creatures developed a standard number of digits at the end of their hands and feet, 5 on each. We know them today as fingers. All species that had more than 5 fingers started slowly disappearing. These pteropods split into 2 groups. The first of them had to return to the sea to lay eggs. This group would later give rise to amphibians. The second kind of tetrapods is more interesting to human evolution. They're considered the ancestors of reptiles, dinosaurs, and mammals. The Permian period came at the end of the Paleozoic. By this time, all life forms on Earth inhabited the supercontinent of Pangaea. There were vast deserts far away from the oceans. The more important species that walked on all fours during this time were the synapsids. They came in all shapes and sizes, but the only subgroup of synapsids to survive into the Cenozoic were the mammals. Doesn't seem like much, but we exist today thanks to these ancient tetrapods. As a species, we have come far in the tree of life. A recent study revealed that the first life form to evolve was an ocean-drifting comb jelly. This came as a bit of a surprise. For a long time, researchers believed that the simple sponge was the oldest animal on the planet. After analyzing vast amounts of data, comb jelly came on top, or the bottom, depending on how you look at the tree of life. These ancient beings were squishy and had tentacles, but they weren't the true jellyfish like the ones we see today. The creatures lacked the bell-shaped body and stinging cells. Scientists cannot precisely date the species because they lack a fossil of the oldest comb jelly. This is not the case with other ancient creatures that once roamed our planet. The ancestor of dinosaurs, turtles, and crocodiles are familiar to science. These are the animals that appeared during the Paleozoic era. This was a time when true tetrapods appeared. Paleontologists recognized them by 2 distinctive openings on each side of their skull. The first mammals that appeared during this era resembled reptiles. It would have been hard to distinguish them from dinosaurs. Some of them later evolved features we all know today. These include fur and a warm-blooded metabolism. They developed during the time when dinosaurs dominated Earth. That's why these first true mammals were small. Most species weren't bigger than a mouse. Their diet consisted of plants, as they were herbivores. Also, they were creatures of the night. During the day, they were mostly hiding underground. Now, this wasn't such a bad strategy. Some 66 million years ago, an asteroid fell on the Yucatan Peninsula in today's Mexico, and this spelled the end for dinosaurs. 75% of all species that lived on Earth at the time disappeared. The mammals' small size helped them survive and repopulate the planet. The era in the history of our planet that followed the Mesozoic was nicknamed the Age of the Mammals. The climate became warmer, so grasslands expanded. These were the ideal conditions for tetrapods to grow in size. Some mammals decided not to take this evolutionary path. Bats remained relatively small in size and took to the skies to join birds. And there are some tetrapods that returned to the ocean. The most notable example are whales. Today, their closest living relatives are hippos. Both species are aquatic, but they developed this trait separately. The first whales were actually tetrapods. These were the most typical examples of 4-legged land animals. If you saw them today, you would think they were oversized rats. That's what whales looked like some 50 million years ago. Paleontologists came to this conclusion in the 1980s by studying the skull of a now extinct animal. It lived around the edge of a large, shallow ocean. At some point in history, it returned to the marine way of life. Its back legs devolve. But sometimes, biologists stumble upon a living specimen of a whale that still displays tiny hind limbs in its skeleton. It's like a reminder of a long-gone era when its ancestors walked on all fours.
How heavy is the largest living snake? How can a snake eat a whale? Get ready, I'm about to answer these questions. Before the last ice age, giant mammals like mammoths ruled the world. The modern animal kingdom we're familiar with was shaped around 55 million years ago. I mean, there were still 1,000-pound bear dogs living from Asia to America. But modern whales, for instance, began to appear later. I'm saying modern whales because, surprise, surprise, whales weren't always fully aquatic. The ancestors of the ocean's biggest animals once walked on dry land. They had 4 legs and lived on the coast. Now, I want to introduce you to a snake that used to eat these whales, the Paleophis, a genus of a marine snake. Scientists say it's hard to understand how big the Paleophis was due to its fragmentary fossil record. They assumed that it could have reached up to 40 feet long. Its fossils were found in different parts of the world, from England to Morocco and Virginia, USA. The Paleophis is extinct now, and sea snakes today are only about a quarter of the size this majestic creature used to be. So no need to worry about this underwater monster. But there once was an even bigger snake, the Titan boa. It was around 50 feet long and most likely weighed over a ton. It used to live in what is now known as northeastern Colombia around 60 to 58 million years ago. Scientists say that it mostly fed on fish. Another giant animal that lived in the past was the black Gigantopithecus. These primates aren't related to gorillas. They lived in the area of modern China. Some people believe that they're still alive, but so far, no one has laid eyes on them. Some people even go further and say that the stories of Bigfoot or Yeti are based on these animals. This rodent became extinct about 2 million years ago. Its main habitat was South America, more specifically, Uruguay. What's astonishing about this species is that it was the largest rodent ever known. It was bigger than a bull. Scientists believe that it weighed up to 1,000 pounds. A distant relative of this rodent is still alive today. It's called the pacarana. It's a rare animal that lives in South America. It weighs up to 33 pounds and measures up to 31 inches, not including its cute and fluffy tail. The Arthropleura was an insect that lived in prehistoric times. Imagine a giant millipede measuring up to 8 feet in length. Here you go. It was one of the largest land animals of its era, about 315 million years ago. The Arthropleura's shell was covered with tough plates. These plates were there to protect the creature from damage. Most of the time, it burrowed into the ground to avoid becoming some other animal's dinner. Meet the Megalodon. Millions of years ago, this shark lived in the ocean and ate other marine creatures. It had wide teeth, and its jaws were so powerful that the animal could finish off its prey with the force of its bite. It was one of the largest sharks to ever exist. Yet, this predator also went extinct. Scientists don't really know the reason. This made me wonder why animals were so big in the past. Nowadays, smaller creatures flee or hide from predators. But apparently, it wasn't like this before. Many centuries ago, animals didn't just run or hide, they fought back. Research suggests that this behavior may have been the most important motivation for prey to grow bigger. A study compared the skulls of ancient animals to those of their modern peers. The skulls of predatory animals have become shorter and narrower, while the skulls of the animals they hunted have become longer and broader. This means that predators learned to become experts in hunting, while prey worked on developing their defense skills. You see, a larger body size was a great advantage because it made it harder for predators to take down the animals they hunted. The bottom line, self-defense made prehistoric animals larger. The second reason why ancient animals were larger is related to their bones. They had hollow bones, which are lighter than solid bones. This type of bone allowed large animals to move quickly. Let's take sauropods. They were a dinosaur subgroup. Sauropods had giraffe-like long necks and snake-like long tails. Compared to their body size, their head was really tiny. But since their bones were quite light, they could move around without having to carry additional weight. The eating habits of these animals were also related to their body size. When experts examined the fossils of one extinct mammal species, they found out that these animals had a diet that was high in nutrients and low in fiber. And this mammal was the largest land animal of its period. In other words, following this diet, mammals could grow to be very large. There was plenty of food out there, so they didn't have to worry about finding it. Fun fact, these animals also took chewing out of the picture. They could swallow their food in large pieces instead of taking small bites. Environmental conditions also played an important role in the evolution of larger animals in prehistoric times. Those animals tended to live in warm, moist climates that provided them with a lot of food. They didn't have to compete for food sources. Researchers believe that because of these conditions, natural selection worked in a certain way. I mean, body size was more important than such traits as agility and speed. Oh, and did you know that large animals tend to produce more carbon dioxide? And ultimately, a bigger volume of carbon dioxide increases the amount of vegetation in the animal's habitat. As for the abundance of oxygen in the atmosphere at that time, it could be another vital element for some animals' growth. A good but scary example of an animal that benefited from the high levels of oxygen can be the cockroach of the Paleozoic era. At that time, cockroaches were the size of modern house cats. Now this one would give me the chills if I ever faced it. Ugh. What about today? Well, there are over 3,000 species of snakes on Earth. The smallest snake in the world is the Barbados thread snake. It's only around 4 inches long when fully grown, and the largest one? It's the reticulated python. This snake reaches around 20 feet in length. The longest python was discovered in 1912. It measured 32 feet long. As for the largest and heaviest reticulated python, it was named Medusa. Medusa was approximately 25 feet long and weighed 350 pounds. These reptiles lived in Southeast Asia in rainforests, woodlands, and grasslands. Don't be confused though, the reticulated python isn't the heaviest snake in the world. This title belongs to the green anaconda. It weighs approximately 500 pounds. Green anacondas are found in South America and Trinidad in damp, humid areas. I have a bonus for you. Here is a flying snake. You can find these snakes in Southeast Asia. They don't fly like birds, of course, but they do use the power of flight. They can go as high as 300 feet. They leap from tree branches into the air. Once they take off, it's all about aerodynamics. Their main technique is flaring their ribs and pulling in their abdomens. While airborne, they undulate from one side to another and slightly up and down. This motion helps snakes to turn and glide. Why bother with all this if they can just crawl in an old-school way? Scientists aren't sure, but they believe it might be related to escaping from predators. This way, they move from one tree to another without having to get down to the ground. Every now and then, people discover fossils of animals that lived millions of years ago. These ancient discoveries continue to capture our imagination. Which of these animals would you like to see alive? The megalodon was the biggest shark to ever live. Not only that, it's one of the biggest fish and the largest predator in Earth's history. Over 3 times longer than the biggest great white shark on record, the females have also been found to be twice the size of the males. The megalodon could swallow a small car without even touching its teeth, if cars had been around then. In fact, the Meg was so big and powerful that it had no natural predators. It was the uncrowned king of the seas, swimming freely from ocean to ocean. This cosmopolitan creature was found all over the world from America to Europe and Australia and Japan, assuming there were countries back then. Meg fossils have been found on every continent except Antarctica. Everybody skips Antarctica. Science tells us that the megalodon went extinct over 3.6 million years ago. But could they still be alive at the deepest depths of the ocean? The fearsome name, megalodon, comes from two Greek words, megas, meaning big, and odont, meaning tooth. Combined, they mean big tooth, and it certainly lived up to its name. Just one of its chompers is the same size as a human head. It had 276 humongous teeth in total, across 5 terrifying rows. In all of history, only a couple of saber-toothed cats and the T-Rex had consistently bigger teeth. Now that's a showdown I'd like to watch. The megalodon vanished millions of years ago, leaving only huge teeth to be found by modern archaeologists. Only around 80% of the ocean has been explored, so who knows what's lurking at the bottom. If you did manage to make it down, it's unlikely that you'll run into Meg though. The sharks, like us, preferred warm coastal waters. Deep ocean living would be too cold for the beasts, and food would be scarce. Their entire bodies would also have to evolve to avoid being squished by the enormous water pressure down there. It's unlikely that they're still around, but not impossible. Now, about the appearance of the megalodon. Scientists believe it didn't look like a great white shark. The megalodon belongs to a different fish family and most likely looked like a giant sand tiger shark. Flattened snout, small eyes. Its dorsal fin moved backward. The sand shark has 2 dorsal fins about the same size. The coloration is light brown with a white belly. It may have had brown-red spots like a sand shark all over its body. We used to think of the megalodon as something scary from the first finds of its fossils. That was back in the Renaissance era. People found some teeth in the rocks. At first, these teeth were thought to be the tongues of dragons or snakes. And here is the first drawing of what the owner of these teeth supposedly looked like. A massive snout with a scary nose and a bunch of razor-sharp teeth. The megalodon is usually described as a sort of giant great white shark, but this is just a common myth. In fact, the ancestors of today's great white existed at the same time as the Meg. But they weren't the best buddies and were even in competition with each other. The great white shark was a better hunter, using its smaller size and agility to snap up Meg's prey quickly. They were also known to eat Meg pups, who were only half their size. This didn't help the whole extinction thing. We also have evidence that megalodons were brutal hunters, kings of the food chain. The first combat tool in their arsenal was the battering ram. The megalodon would take its prey by surprise. It had only one chance to hit it. If it missed, it would take too long for a second round. The maneuverability of the megalodon was comparable to a large truck. While a great white was no match for an adult Meg in a head-to-head fight, they sure weren't scared of stealing their food. This only left the bigger fish and whales for the Meg. But its food supplies began to run out as the whales swam to the cooler new seas. The whales adapted to prefer the colder temperatures, leaving our friend the Meg behind. The megalodons either starved or were frozen into extinction by the Ice Age. Rather than a great white, the megalodon is more like a modern bull shark. It had a short snout, a flat lower jaw, and huge pectoral fins to support its massive weight and size. As scary as they are, these sharks were actually caring family guys. Several megalodon nursery areas have been discovered in Florida, Maryland, and Panama. They gave birth to their young in shallow water environments. We know this from discovering loads of tiny megalodon teeth found in these areas. I wonder if they had nannies too. But how come there are so many megalodon teeth out there for us to analyze? Due to their messy, aggressive eating habits, sharks regularly lose their teeth. They lose a set of teeth every 1 to 2 weeks. That's 40,000 teeth in a lifetime. They must rake in a fortune from the tooth fairy. Because of this, their teeth were continually raining down to the ocean floor. Luckily for us, they're also the hardest part of the shark skeleton, which is why so many teeth have survived and become fossilized. It's fair to say the first discoveries of the Meg's teeth confused people. Early discoverers thought that the Meg's teeth were petrified tongues of ancient serpent creatures. They even used to call them tongue stones. It's also a common myth that the megalodon was around at the same time as the dinosaurs, although this would have been pretty cool. The dinosaurs were wiped out around 66 million years ago, but the megalodons came much later. The oldest Meg fossil is only around 23 million years old, but it's tricky to pinpoint the exact date. After all, calendars weren't invented yet. They became extinct way before humans even evolved. The earliest Homo sapiens, which is a fancy name for the first humans, emerged about 2.5 million years ago. But what if the megalodon shark didn't go extinct? Whale populations have dropped drastically since these guys were last around, so there'd be way fewer whales for them to chomp down on. Whales have also gotten a lot smarter and learned new defensive moves, making them way harder to take down. It's estimated that they ate around 12 tons of food each day. The Kraken is a colossal squid, a legendary sea monster, the biggest hunk of calamari you ever saw. And if this monster had existed, the world would have changed beyond recognition. The Kraken has powerful tentacles, solid muscles with suckers at the end. They're impossible to escape. The Kraken can break a ship in half, or just pull it down into the depths. But the worst thing about the Kraken is its size. According to old sailors' stories, its size is almost 10 soccer fields. Hey, maybe the Kraken could play soccer. The Kraken legends said the monster was so giant that sailors mistook it for a small island. In past centuries, it would have been impossible to defeat such a beast. If the Kraken existed in reality, it might have had offspring. Yeah. In all the world's oceans, there would be giant monsters that could sink any ship. It's unlikely that the Kraken would have competitors in its habitat, so its population would grow strongly. Since the Kraken is enormous, it would need a lot of food, so the population of other large sea animals would fall significantly. Blue whales, great white sharks, other giant squids, all the big sea creatures would be endangered. The Kraken belongs to the cephalopod genus. This species includes squid and octopus, some of the most intelligent creatures on the planet. The Kraken is a skilled hunter and will never fight in the open. Colossal squids live in deep waters and they have the largest eyes among all animals. The squid's eye is the size of a dinner plate. Thanks to this, they can see their prey from far away. Similarly, a Kraken would spot the ship much sooner than sonar could pick up the Kraken. It would always have the drop on you. Well, that's not good. In 1857, a squid beak was discovered on the coast of Denmark. Other huge squid remains were found in the Bahamas, and then scientists were convinced that gigantic squids existed. While colossal squid have been officially discovered since then, it's been more than 100 years and we still don't know what the max size they can grow to. The fact is, colossal squids are one of the most elusive creatures on Earth. They live in the depths of the ocean where it's challenging for scientists to reach. Any dive to a greater depth requires powerful, bulky equipment. Underwater bathyscaphs and cameras make a lot of noise and light, which squids notice from afar. They flee before we can see them. It's difficult to say if these huge squids were the size of a small island, but the truth is, we've only studied about 5% of the ocean. It may be that in its depths, monsters much more terrible than the Kraken swim.